You're listening to Within Tolerance, a podcast for a machinist by a machinist. I'm your host, Dylan Jackson from Proteum Machining, and this week I am very happy to welcome Alex Kern. Welcome, Alex.
Hey, thanks, Dylan.
I
Yep.
appreciate you joining me. I know I've got a ton of questions for you from the listeners. So, for anybody who doesn't know you on Instagram, Chief Bub, who are you? Where do you work? What do you do? All that good stuff.
Yeah, so I am Chief Bub. I'm Alex. Um, I am a machinist. I work at a company called Wilsey Tool. It's technically not called Wilsey Tool Company anymore. Um, we are owned by a larger company called Arch. Some of you may know who Arch is. Maybe you even work at companies that are Arch companies. But yeah, so we got purchased by Arch like, I don't know, last year sometime. And anyway, yeah, I'm just a machinist and do stuff, make parts. I don't know, do dumb things that shouldn't be possible, but things of that nature. So,
Yeah, you
yeah,
are far too modest. And for anybody who hasn't seen his Instagram, go check it out. I'll definitely link it in the show notes. You do some amazing stuff. You guys have some of the coolest machines, in addition to some basic Haas that you've tricked out with some super cool automation. You guys do some really fantastic machining that is,
thanks.
is
I
worth looking
appreciate
at.
that.
Yeah.
I appreciate that. It's kind of you to say, but yeah, it's kind of junky stuff. So,
Yeah, Arch is giant though. Like I know them because of the cutting tool division, and I've
right.
purchased Arch tools in the past and stuff. But I didn't realize. I feel
Keo.
like yeah,
Keo is Arch. Yeah.
exactly. When I want to say that I saw somebody else on Instagram that their company also got purchased by Arch. Like it seems like they're just massive.
They are. They are. And they're a business, so they sell their companies too. So I'm not getting my hopes up that we won't get sold or anything like that. But I know before they bought us, they bought, or no, they sold their aerospace division. So, and I could be putting the wrong numbers out there, but this is something like they sold 1,200 employees worth of businesses. So if
Holy
you,
crap!
for all you guys who are entrepreneurs out there, think about that for a minute, and then think about like acquiring 13 businesses in, I think it was 13 in a year, or that doesn't sound like enough. But when they acquired us, like I think in 2021 we were their 13th business of the year, I think. And when I say us, that's actually three different companies that they bought at once. Um, so yeah, it's insane if you think about it from an HR perspective. Like, how do you onboard all these people? And it's just crazy. But they've been pretty cool. So I would actually be interested if any of you guys listening are Arch employees. Reach out. Like, I'd be kind of cool to hear your thoughts and your take. And it's been really good so far. So I have nothing bad to say. Yeah.
Well,
So anyway, yeah, that's
that's great
just
to hear.
something stupid about Arch. Yeah.
No, that's cool, and I think that that's something that maybe a lot of people don't have experience with. So it's really interesting to bring up.
Yeah. Yeah. Don't be afraid if you guys get acquired. Don't be afraid. It's usually good because usually the people acquiring you have more money than what you had before. So, you know, you might be able to spend some of it. It's kind of
Right.
cool.
Exactly. Well, we've got lots of questions about future acquisitions you guys have made, but before we get there, let's dive back. How did you get to be a machinist? How did you get into the trade, and how did you get to where you are now?
So the answer to that question is sort of long, but I guess, we have a while on the podcast. So the company name is Wilsey Tool Company. And essentially, I went to the same school as Andrew Wilsey. He was actually in my sister's grade. So he is the son of the former owner of the business. And the former owner of the business is the son of the founder of the business named Bill Wilsey. So I ended up being the yard boy for Bill and pulled weeds out of his gardens and just do whatever stuff when I was like 13, 14 years old. And then once I was, I guess, 15, I could be getting my numbers wrong, but I was 15. However old you have to be to get your working papers, I think it's like 15. Do you know?
I think it's probably dependent on the state too.
Yeah, so PA, whatever. Um, I was working in the garden and doing just lawn stuff. And Tim Wilsey, I don't know if I should be using their names on the podcast, but I think it's fine. Bill has long since passed. He was pretty cool though. But yeah, I ended up in the shop. So I ended up just having a summer job. And first, I started out doing quality related tasks. So, here, wind this thread gauge in like these thousands of screws. Okay, cool. I said, can't we like get a torque? I was already thinking of dumb things like, can't we get like a torque limiting device to put onto a screw gun and just wind them in real fast? And if it's like, if it's too tight, it won't go in. But yeah, of course not. No, that'd be too easy. Um,
There is nothing that makes you want to fall asleep at the job too, like thread gauging parts.
Yeah, and I kind of liked it. I liked the process perspective of it. I'm like, okay, I'm going to put all these things in this pile and here's my piles and try to count them. And there was just a lot of learning how to work, I guess, and not be lazy. But I look back and think, man, I probably was pretty lazy. Um, so yeah, doing stuff like that. Also, I helped with laser marking if they needed help in laser marking. So I would help. She's actually still one of my coworkers. I would help her. And we did laser marking and chemical etching, if you guys are familiar with that. We would do chem etching of rods. So, by the way, everything at this shop is medical device. Um, Wilsey Tool Company started out in, I think, I'm going to get this wrong. I want to say it's 1955 or 1959, or sorry, I don't know. I really should, but started out early on in Bill Wilsey's basement, which is pretty cool.
Oh wow,
So
that's really
yeah,
cool.
yeah. So you talk about entrepreneur and stuff like that. Like this guy was pretty cool. Started in his basement, and the company was actually doing cutter sharpening. So um, a lot of grinding and the natural evolution from a grind shop. I think there's different directions, but EDM makes a lot of sense, right? It goes hand in hand with grinding precision. So then we were, I'm kind of making this up, but I would guess that we were an early adopter of wire EDM. So the quality manager, the old quality manager, another one of the Wilsey family, Mike Wilsey, he was always really good to me. They were always super good, but he learned wire EDM, and the machine was called an Andrews wire EDM machine. It's like really cool in the 1970s.
Wow,
Yeah,
jeez.
right. So we're talking old school. So super slow. I can't even imagine how slow it is. We actually still have the surface plate. I'll have to post a picture. The surface plate's really cool. I haven't posted a picture yet, but it's a Starrett surface plate, and it's all granite. So the legs are also granite. They're like
Really?
yeah, it's really cool. Um, it's it's heavy, and I think it's all just glued together, but it's all granite. But we still have that surface plate, and the old machine used to sit on it. Anyway, how did I get into manufacturing? Yeah, we're way off topic already. But
Well, it's just cool. Also, like I've noticed that it sounds like it was very much a family business up until very recently.
yes, it
That's really
was.
cool.
It is cool. Yeah. So it started as that and finally Bill bought a building. He bought a piece of land and he built a building. And you can actually see the outline of the building. Like if I would take you through the shop, I could show you. It could be like, hey, check this out. Here was the back door, the first original building, and it's just really kind of cool because it was so small. And some of the machines that we still have in the shop actually were in that room. So like some of the older Mitsui grinders and stuff like that, which unfortunately we got rid of a lot of that stuff just for like scrap. So some nice, yeah, it doesn't really matter, but some cool stuff, right? Stuff that you'd want for your house.
Right.
Um, so anyway, yeah, it was family business. I worked there and it was really just a job for me. I kind of liked it, but I had other interests. I was more interested, like in high school, I did a blacksmithing project. Me and my friend wanted to make knives for our senior project. So we like forged knives and stuff, right? And I remember asking the grumpy old shop foreman who eventually became my mentor. I asked him one day, I'm like, hey Jim, you know any scrap yards around here? Because me and my friend were looking for scrap steel to like, heat up and beat on and try to make a knife on an anvil, right? So I said, Jim, you know any scrap yards around here? And we were like washing our hands at the end of the day or something like that. And I was always afraid to really talk to him. But I asked him because I figured maybe he knows. And his answer was, "You're in one, right? You're you're in a scrap yard." Like, yeah, okay, that's true, I guess. So anyway, I did like so with Jim. One summer, the first summer I worked in quality. Second summer, the second summer I was old enough. I think I was 16, so I was old enough to run a machine, which changed things. And yeah, I remember some things like the owner. He said, "Okay, so you're old enough to run a machine now. Do you like if you do that?" Like, it was kind of like a turning point almost. Like you are almost as if I had a choice, like a choice where I could stay more. I look back at it now and I kind of see maybe what he was saying, but he basically said, "Do you want to do that? Like, you would go out, you want to go and be a floor guy?" And I said, "Yeah, I want to." So that's what I did. And I think maybe what he was doing was warning me because of what I had to do. What I ended up doing that summer was grinding. Grinding, if you're familiar with, I mean, most people are like a table saw blade
Hmm.
and the carbide inserts that go on the blade, they're brazed in, right? So these carbide inserts would come as just the, I guess, sintered pressed carbide thing, blank.
Right.
So we had to grind them, and there were 2,000. So there were, I think, I don't remember how many operations. It was somewhere around 10 operations on 2,000. So like if you've never, anybody who's never used a surface grinder before, you kind of look, your toe. It's like tapping your head or rubbing your head and patting your chest or whatever, right? It's one of
Right.
those things where you mess up every time. So yeah, I learned very quickly how to use a surface grinder and grinding 2,000 of these freaking stupid little carbide bits. It's like, oh my god. And Jim, he would say, yeah, if I had to do that job, I would like hire a contractor, sub it out. Like, I'm not doing that. Like,
Right.
yeah, but you make me do it. So
I'd hire a
anyway,
16-year-old.
exactly. Hire a 16-year-old. Oh my god. So I guess it builds character, but
Well,
yeah,
and that I'm sure could be a turning point for a lot of people. Like if you didn't like that and you weren't willing to push through it, maybe that was a good
yeah,
scare off point for some people.
right. So, and that's a good point. So, and kind of helps me explain a little bit. At this point, all I was doing was just getting a paycheck. I had no idea what I was doing. I was just working there and I was able to do the tasks that they asked. I was capable in some sense, but I didn't know what I was doing. Like I didn't there was this guy, this other like real old guy there. His name was Steve. He was so cool. And one day he told me a story and I don't think I remember it that well, but he's like, "Hey, do you know do you know what you're actually doing?" And I'm like, I still think about that. Like, what was he actually saying that day? So I remember it. Do you know what you're actually doing? Like, what are you making? And that's sort of part of what I preach to a lot of people that I work with. Like, what are you guys, what are you making? Are you just Are you making a diameter? Are you turning a part? Like, what does that do? What does it do? Is it, does it go into something? Does it need to be a press fit? Does it need to have any sort of special assembly requirements? Whatever. So anyway, I had no idea what I was doing. I had no appreciation for it. I was just like, oh, I get paid more than $6 an hour, and it's kind of cool. And I get to work summers and work flexible hours, and I guess I was sort of kind of the golden child also too. So it was good and very bad at the same time. Um, so yeah, worked summers, kind of worked in every department, except I didn't spend a lot of time in EDM. I spent a lot of time in graphite, doing graphite work. So like,
Oh, really?
yeah, taking doing like stupid stuff, sawing the blanks. Like if you've ever done that, that's not fun. You saw the you take the giant block of graphite. It's like, 6 inches thick or maybe more, 8 inches thick, and just it's not really that heavy, but it's giant. And you cut it on the bandsaw. You pushing on it with like all your weight for 10 or 20 minutes just to make a cut, and then slicing it, setting up the fence and slicing it into little pieces. And now you have these little square rough cut blocks that you put into a lathe, like the worst condition lathe you can imagine. This lathe is just beat to hell from all the graphite.
Right.
Um, like if you think your lathe feels loose, you have no idea. Like, we still have this thing. We have this lathe. Some guy who used to work there he just like brought it in for graphite and it's still there, so it's funny. Anyway, yeah, then you got to turn the shank on it. If you're familiar with 3R, uh, the 3R 20 millimeter electrode holders, you shove the round shank, you press it in and tighten the set screws. Anyway, then you put the electrode, you grind it or mill it or whatever needs to be done. And then when the electrode's spent, you got to knock them out. So I did a lot of the knocking out. So you get these
Oh,
racks of electrodes, and you got to loosen the two set screws and beat on it with a, I don't even know what we used, like ejector pins or something like that, and just try to get the electrode out and get you good practice like hammering something. I'm still not good at hammering, but hey, whatever. So just basically doing menial shop tasks for a long time. Even running Swiss lathes, like all the way up to Swiss lathes, Willemens just operating. Still didn't know what I was doing. Just had no real, it was a job. Didn't really have a strong interest in it. I didn't know what I wanted to do. I took a year off between high school and college and just worked. I just worked for a year. So then I went to college and it was okay. It was college. I mean, um, and still I would come back on summers and just working, and it was what it was. And then in my senior year, I found, so I went to Penn State. So there's this place called the Learning Factory, which some of you guys may know. It's where they build the Formula SAE car. And I was like, oh,
oh,
cool.
cool.
Yeah, yeah, super cool. So I've always been interested in cars. Always. It's always been one of my things. And I found this place and I'm like, whoa, this is really cool. There's this car, there's a TIG welder. They build everything from scratch every year. And this is really cool.
Well,
So
Penn State's a pretty competitive team, right? Because
they
like there's
used to be, they
there's
might
like
be
what
now.
five
Yeah.
or like eight teams that like really kill everyone every year because they've got so much
Yeah.
funding, and I feel like I've always seen Penn State up there.
Penn State I think used to be pretty strong, and then they went through a slump, and the slump like was when I was there.
Oh,
Yeah, they weren't very good, but I didn't get yeah, there's a lot more to the story. So, I'm not an engineer. All these kids were engineering. They were like mechanical engineers, electrical engineers, whatever engineers.
what was your what were you
So
going to
my
school for?
yeah, so my major is in kinesiology, which is the study of human movement.
Hmm.
So I had always thought, maybe I want to do like prosthetics and orthotics.
Oh,
But what I
cool.
really was interested in was maybe building the prosthetics. So I guess it took me a little bit long to realize that if you're a CPO or a orthotist, hard to say. If you're that, you're not really building anything, you're really fitting them and you're working with the patient. And like I'm not if anybody who knows me knows I'm not really like much of a people person. Like, I am, but it's can be a struggle. Um, so anyway, the Learning Factory at Penn State, really cool machine. It's a machine shop. It's where the students do their senior design projects and stuff like that. And it's also, yeah, where the car is built. So I was like going through this crazy time where I was just like interested in everything. Just, oh, I want to learn that. I want to learn this. And I always wanted to learn how to weld. And the shop guy, kind of the shop mentor, or he looked after everything. His name was Carson Baird. And at the time, which would be about 10 years ago, he was probably like 80 years old or 78 years old or something like that. I'm not sure if he's still living or not. But this dude had like a profound impact on my career. Um, I would, once I met him, I was just like, wow, this guy's awesome. He was an old race car driver and crew chief, and
Oh
like has
wow.
so many cool stories. He raced in the 24 Hours of Le Mans in 1983, which was he got sixth overall
Holy
in
crap.
like the crappy Ferrari that got lost to all these Porsches. So it's really interesting. And I just talked to him. I would go there every morning and like drink coffee with Carson before class. So nobody was there yet, and it was just Carson and I, and we would talk. And he taught me how to TIG weld. He was a really good welder. He did all this crazy stuff um, before the race, like at Le Mans. They did crazy stuff. They cut the springs so the car didn't oversteer. Like they cut the front springs to make the car understeer. They just cut them. Stuff that it's just people don't really do that. He
Right.
made the flywheel for that car. He brought it on the airplane. He made it at his house. Cool stuff. So this guy was pretty rad. Um, so yeah, he taught me how to weld. He taught me how to machine stuff, and like just got me kind of started. And then my boss saw that, and he's like, "Ooh, okay." And then when I came back that summer, he put me with who was my first real kind of hands-on mentor. I had other mentors, I guess you could say, in my life, but as far as a career goes, he was my mentor. And yeah, his name's Jim. And I still work with him now. We're working side by side, which is cool. Um, but yeah, that's really when the light bulb turned on. So I worked with him doing turning and milling and all manual work, grinding. If you look at, if you look back pretty far back, like on my Instagram, you'll see some of that stuff, and it's all very dirty and crude. But we were making surgical instruments, custom instruments. So Wilsey Tool at that time was largely an implant manufacturer. So we had and still have a bunch of Willemans, a bunch of Star Swiss screw machines, Matsuras with trunnions. It's a medical shop. It's
Right.
not
So like
really
bone
designed.
plates, bone
Yeah,
screws, stuff like that.
right. Yeah, it's not designed to do instruments or drivers or anything really long or weird and funky. It's just not for that. It's not for onesie twosie. So we would do it manually,
Oh
which,
boy.
dressing forms on wheels to grind a shape, or we would, it was all turning and, turning these hardened materials that I cut now. But I look back and go, wow, yeah, that was kind of cool. We were turning it on a hard hinge, right? It was fun. And I really got interested in it then. Like that was really when I started to get interested, um, which is a testament to the guy who was watching and paying attention and said, "Oh, you know what? We're gonna put Alex with this guy now." And I was just, you put somebody in the right position, it can go pretty far, and it's just a nice little lesson. So
So
yeah, that's
when
yeah.
you were graduating, did you decide then and there to like, oh, I want to pursue, manufacturing and stay at Wilsey, or Was this just like, oh, I'll work here until I find what I actually want to do? How did that all happen?
So yeah, good question. I kind of knew that I knew in college once I found the learning factory, once that light bulb like really went on and never turned off, I knew it's like, all right, I'm just gonna graduate. I could either change my major and spend another, I don't know, year or two, however long it would take to be an engineer. And I don't really have any regrets, honestly. There's uh you don't need an engineering degree to be a machinist or a programmer or a manager or anything like that. It helps, but um yeah, so um I didn't really I didn't really think about it like that. I just sort of said I'm going to do what I think I like, and I went pretty much full bore just making parts
Awesome.
and learning. And I enjoyed the vintage tools and the kind of the mechanical nature of just a manual lathe, and appreciated the a lot of the precision aspects of it. I would get into arguments with people about things, and it's kind of cool to look back on it, like, you know, leveling a lathe, taking the twist out of the bed of the lathe. We had a big Clausing lathe there. It was a 17-inch, I think, Clausen Colchester. It's nice. One of the newer ones. Pretty sweet machine. Cut metric threads, and I think it cut metric. I think it did, yeah. It was pretty sweet. And we had to do some couplings. They were drive and pump shaft couplings for a nuclear submarine.
Oh, cool.
So yeah, and we would get the forgings from the customer. It was for one of our, yeah, I think I could probably say it, but it really doesn't matter because we don't do work for them anyway anymore. So it's Curtis Wright. Um, I'm sure a lot of the people listening have seen parts like this, but they're just big round parts with holes in them, but they're closely toleranced. They're very close tolerance, at least for me. And on that machine, it was close. So these bores, the parts were maybe like 8 inches in diameter, and they had to fit together very precisely. I think they had like 2/10 clearance or something like that. So a part that big on a manual machine is non-trivial, especially when you get one shot to finish it, and the machine cuts a crazy taper,
Right.
right? So like the machine cut this ridiculous taper, so we had to put a little indicator on the cross slide, and I'm there with like, my knuckles just tapping as we go, and you mark the boring bar in increments and try to make the indicator go, and here you go, you held your tolerance. And we would inspect them with a CMM and the whole 9 yards. Um, really learned a lot, and I think it was pretty cool that Jim allowed me to do that job. At first, he started me out just roughing it out. So he would say, "Here, do this," and he kind of set it up and um, show me what to do, and we would just rough it, and I would stand there taking rough cuts on this big chunk of whatever material it was, some kind of steel. And then eventually he's like, "Okay, we're gonna finish it." And I was like, whoa. Like, you kind of get that sinking heartbeat kind of feeling in your stomach, like, okay. And he would always make me feel comfortable and confident, like, no, you can do it. It'll be okay. Just follow the steps. So, and we did. I don't think I ever scrapped one. I don't remember. I don't remember scrapping one. I think there's pictures of those on the Instagram also. They're the smaller version though. They're pretty cool. That was fun. We got rid of that lathe. But anyway, the whole leveling thing, I'm like, Jim, we got to check the level of this lathe. He's like, no, no, blah, blah, blah. And I said, no, really. And here, check the level. It was way out. Like, of course, that's why I was cutting such a crazy taper. I mean, it was a real crazy taper, like 1,006 inches or something ridiculous. And you're trying to hold 2/10. Like, come on,
Right.
man. Way to make it easy, right? So we checked level. It was way off. And this machine, I think, had 6 feet. Only 3 feet were touching.
Oh,
So
wow.
Yeah. So once we leveled it, that machine was awesome, and we didn't even have to try. So I think it's a good learning thing, and you can get the most fanciest piece of equipment possible. You can get the most precise thing in the world, and it doesn't make you any better. There's guys out there probably making parts to a thousandth of an inch, and what they're measuring with is like literally a wooden stick, right? Something stupid like that. I'm sure people are doing that somewhere in India or something, right? Guy's running it with his foot or something. And yeah, I mean, so anyway, geez. So that was like in my early 20s, I guess. Yeah. And the light bulb was pretty on, still going more and more on, and eventually I got into grinding, and we had to make these carbide parts one time, and again, similar thing. He's like, we're going to hold a tenth, total tolerance of a tenth. I'm pretty sure that's what it was. And I'm like, okay, how? Right? And I think it's just, geez, I haven't, it's been a long time since I've even thought about these things. So I guess, yeah, with, if you give somebody a good setup and you do the first one and maybe the second one and you do it. I was so slow at this. Oh my God. I look back and see how slow it took me forever. Like now it wouldn't take that long, but you're kind of geeking out trying to hold a tenth and even measuring a tenth. And you just have to trust things. And that's part of it, right? How long does it take you to get that experience that you can just know, no, it's good. It's good. I'm not even going to check it. It's good.
Right.
Like that, because it's all in the feel and the sound and just what you see and all your senses are, it's crazy, right? But
Well, and you start getting down to a single tenth, and like
it's ridiculous.
everything falls apart. It's like,
Yeah.
oh, did I breathe on that wrong? Did I hold my gauge for 10 seconds too long? Did I,
Right.
like
So
everything is moving.
luckily they were very small parts. So you could accurately measure it with a micrometer a lot of times, but we had to square them up. So, now you're using an angle plate and squaring them up and loading a block onto an angle plate with a cant twist clamp. Even again, right? This is Herman Schmidt stuff on a Mitsui grinder. So this is like pretty good stuff. And nowadays I see people like Adam, the machinist, and some of these guys who actually know what they're doing, and they have those clamps that press in, and it presses in nicely from both directions and presses it into the corner of the angle plate, and it's just sweet. So I could see that being much more useful, but I didn't have that. I had a can twist clamp. And yeah, loading it on and trying to get squareness isn't that easy. So all these little things just add up, I guess, into decent experience. So I did a lot of this stuff and doing the instruments kind of after a lot of these production jobs, I would started getting into the instruments for these surgeries. It's all spine stuff. And yeah, we would do it all form tools. We'd grind a lot of form tools. We would grind a lot of forms on the parts, a lot of grinding to achieve weird shapes. So slow. Oh my God. But it was because we didn't have a pathway to interrupt these production machines. Like, you can't just go interrupt a freaking Williman
Right.
that's pumping out parts or a Swiss lathe just chugging along, making 100 screws or 200 screws in a day or something crazy like that, right? You don't want to break that down. It's not what we were designed for. Uh,
Well, and I'm sure you guys had to do pretty stringent inspection stuff too. So if you did break it down, you're back to square one with first articles and a bunch of wasted time on the back end.
yeah, you could be right. I don't know at the time what we were really doing with that, but you could totally be right. Yeah, it's just it wasn't there was no pathway to do this stuff, so we did it manually and it took forever. And yeah, um, eventually I got bored and was kind of I exhausted most of the opportunities that were there. for me at the time. The business had actually been sold. So we were sold twice. We were sold once like 8 years ago to the small company, a small investment group, and then they sold last year. So it had just got, under new management and stuff like that, and it was a little bit rocky in the beginning. And I left on good terms, and I went and worked at a company called Globus Medical, which some of you probably have heard of. They're pretty big in the spine market. It's about 40 minutes from my house, and they interviewed a couple other places, but they eventually called me back, and I was like, oh, I was surprised, blown away, because some of the guys from Wilsey had gone there, and you heard things about Globus like, oh, it's so cool. They, you know, have a really nice work environment, all this stuff, and it's all true. It's totally true. It's nice. It probably is what the places like Facebook or Amazon or Google or Starbucks or some of these weird, any big company or an OEM, they have a nice work environment. It's not a job shop. It's white collar, really. It's white collar. It's not blue collar. So it
Right.
was cool. It was a great environment for learning. And I went there and they hired me to do custom instruments. And their custom instruments didn't have any drawings. There was nothing to work off of. Like sometimes you got a model, but a lot of times it was like, here, take this existing instrument and here's a sketch. Literally, it looks like a napkin sketch and go make this. Or like put this end on this thing and make it do that and hold this thing in this place and all this weird stuff. So there were no drawings. There were really no requirements. It was kind of crazy. Um, Actually, really crazy compared to what we do now. Like you talk about quality and validated processes and just meeting customer requirements, having an actual customer requirement. This was nothing like that because you're working at the OEM. So, they're like, yeah, sure, Mr. Doctor, we'll sell you these screws and give you that cool special tool. Sure, we'll give you the tool for free. So here we are making these tools for free so they can sell some screws or, please somebody. Anyway, it was really cool job. You could pretty much it was night shift, which it was okay. It wasn't a bad night shift. It was 2 to 10, which is pretty cool.
Oh, that's not bad at all.
Yeah, it's like a pretty good shift.
But night shift's
And
kind of rough, no matter what. Like, I've
yeah.
only done one shop that I worked at that was night shift, and I did not enjoy it. And like my business
Mm.
partner, he's coming on full time at the beginning of next month, and he's been working night shift since I've known him pretty much. And man, he is so excited to like sleep a normal schedule and live during, the normal times that people are out and things like that.
Oh my gosh, I'm sure. That's pretty exciting. He's coming full time.
Yeah, yeah, yeah. We're both really excited. I really need the help, and he really needs a change of pace. So
That's really cool. Congratulations.
thanks.
Um, yeah, I have no idea what the whole entrepreneur thing is like, but it sounds difficult, but also it's got to be super rewarding.
Definitely. Yeah. So then, how
Um,
did you get from Globus back to Wilsey?
right. So at Globus, I learned CNC.
Oh, okay. I
Yeah.
assume so if they only had models.
Right. So sometimes you got a model. Sometimes.
Right.
Um, yeah. No drawings. Literally, I don't think I ever got a single drawing. I am not exaggerating. Nothing with a dimension that was made on a computer. It was all just like literally napkin sketches. So anyway, yeah, they had Mastercam and everybody had to use Mastercam. There was no in between. It was either you're making parts manually, just like I did, and that's what I went there and I did that because I knew I could do it. So, but eventually I had to learn CNC. And yeah, everybody used Mastercam and I kind of got into it. They had a I have a whole bunch of Haas mills there, like just little mini mills, some super mini mills, a couple of VF2s, um, two VF2s with trunnions, and yeah, at the time it was like Mastercam X. I think it was X9. It might have been X7, but I think it was X9. I don't remember. So yeah, I learned a lot there. You could pretty much just learn as much as you want. Anybody, there were no real expectations. Literally, there were no deadlines. It was just like, it was really easy.
That sounds amazing.
Yeah, it is amazing. It depends how you're wired. So for me, it eventually got to the point where I'm like, man, I'm working. Like, I'm here to work. And there's a lot of people here, like, literally sleeping. Seriously, the one guy got fired for sleeping behind a machine. They caught him sleeping behind a machine and walked him out right away. He's just sitting there sleeping.
Yeah, you can't do that.
Like, dude, it's
Yeah.
it's it's actually really, there's so many funny things from that company. So yeah, I worked there for almost exactly a year,
Okay.
and I got bored, and I just missed something. I think it might have been partly the the guy sleeping, and there were some of us who were really working hard and really learning a lot of stuff, and they weren't even doing dynamic milling. But my friend and I were like, I started messing around with it. And there was this guy there who would bring his laptop every day. And I'm pretty sure what he was using was Fusion or HSM Works, like early, because he was doing like cool stuff, but he kept it to himself. It was weird. But yeah. So we started using dynamic toolpaths, and everything was like AccuPro tooling. Again, you don't really need anything fancy. We did some cool parts. So yeah, cool stories from there. Like we literally copied a part. Um, a surgeon wanted to use he's like coming from another competitor, and a competitor's part or competitor's device, let's say, and we had to make him one that he would like. I tried to make him one, and God, looking back at that thing, it was hideous. It was like the worst part ever, the worst design. It was terrible. So what the rep did, these reps are crazy for spine and probably any medical device. They're crazy. So the rep literally stole the part, or stole, I keep saying part, but it's an instrument. He stole it. It's a reducer. Um, he stole it from the hospital and mailed it to us. Same day, like the most expensive, like crazy priority mail you can get,
Right.
same day. And then we had to mail it back that same day. So we got to like look at this part and see how it worked and stuff. And it's like espionage or
Right. That's
something,
what I
right?
was
It's like
about to
super
say.
shady. Yeah, he took it out of when it went to cleaning, so the autoclave room or whatever they do in hospitals. Yeah, he just took it. So it was all like nasty. It wasn't really bloody, but it was kind of nasty. So anyway, Globus was pretty cool. I liked it. Um, Met some cool people. So then, this whole time when I was there, I left Wilsey, and they told me, they said, well, you should probably stick around because like there's things in motion, there's balls in motion that are really good. And I'm like, well, what are they? And so, well, we can't tell you, because I guess it wasn't really final at that point. And yeah, I wouldn't say anything either, because you don't really want to change somebody's life based on something that's not true.
Right.
So
But to your point, you don't stick around for a promise of future gains.
exactly. So I'm not just gonna like hang out. No. Um, so this guy came from another company doing surgical instruments really, really well. And he left that company and went to Wilsey when I was working elsewhere. This guy is now my boss. So he's the one. He's the one who created what what we do now. What you see on Instagram is from him.
Okay.
So when I got back to Wilsey after that year, there was one of the Sharp knee mills with the Accurite mill power control. There was one of those, and there was one of the ProtoTrack lathes. And we were doing instruments now in its own little area. So the problems that we had with the lack of technology, we're making instruments manually and grinding and all this crazy stuff. the problems that we were having with that were starting to get solved. So we were creating a pathway to do more instruments. These are all customs, so very low volume, um, 2, 3, 1, 5, maybe 10 if you're lucky at that time. So he was there, and yeah, this guy is my boss and mentor and everything currently. So that was 6 going 7. It'll almost be 7 years ago. That was 7 years ago that I went back, and that's what we started with. Um, so yeah, we're doing a lot more now. Um, the volumes have gone up, which is weird. And it's just like volumes in general, I think, have gone up. I don't know if it's something having to do with the current state of the world with manufacturing, but people are ordering more. Everybody just wants more and more and more. But
Well,
yeah, so we
everybody's
started
probably
with,
worried about not being able to get anything anymore.
yeah, I think it's partly that. And I think it's just, there's just more people have more money. There's more money everywhere, so people are gonna get more surgeries. People are gonna be trying to do. These doctors are gonna want to do fancier stuff, and yeah. So we started with that, and we worked our way up to in the past 7 years from shipping $50,000 a month in instruments, maybe 100,000 on a really great month, like really really great. Now we're doing a lot more than that,
Right.
right? We're shipping like 600 some months, 700,000, which is pretty cool.
And that's
And
amazing.
that's not all my group. I just have to say that's the transformation of the business. So I had said that we were doing a lot of implants. Well, we're doing a lot of instruments now. So it's those Swiss lathes are now set up running production instruments. So it's really been a transformative 7 years, and really like took it we took it on ourselves, just that whole thing, like take ownership.
Mhm.
Yeah, well, that happened, so didn't really wait for anybody to tell us what to do. um, I would attribute a lot of the success to just good management from above, kind of hands off, but make sure people stay on the right track. And yeah, you just read that Paul Akers book one day, The 2 Second Lean,
Mhm.
right? Have you read it?
I think if I haven't read it, I've watched most of his videos, but I want to say I've read it.
Yeah, the book's pretty good. I've watched a lot of his videos too. I should reread the book just to get a little inspiration, because it's almost like petered out a little bit. It's tough to keep making improvements. It's tough, but it's really not.
Yeah.
It's really not. Um,
I don't
it's
do like one a day, but I will say now that I work for myself, I do spend, if I know like if I stumble across something, I do it immediately first thing in the morning. Like that is my go-to thing
Yep,
because it energizes me for the day. I'm like, sweet, I got that out of the way. It's never going to be a problem again. On to the work. Let's get some parts out.
awesome. That's the way to go, and that's what we do too. So it's largely a lot of the way that we work is largely thanks to Paul Akers and also Jay Pearson. I really have a lot of respect for Jay Pearson. He's no slouch. Really cool and innovative. And yeah, so we copied him with the do it in the morning, clean in the morning. I like how he does that instead of cleaning at the end of the day. Um, so it's largely been not only a shift from product mix from implants to instruments, but it's also been a culture shift of continuous improvement and not leaving well enough alone. You don't just settle. There's some, you gotta have that ability to settle and say, no, that's good enough. Don't even touch it. Just let it go. It's fine, right? And it takes a. You kind of gotta go. You have to go too far sometimes to then bring yourself back and say, yeah, that was just crazy. That was stupid. And here we are, and now I can see it. Right now we can go back to something simpler. Um,
Did you guys have people pushing back against that culture change, or was it kind of the full group?
yeah, totally. No, it was. So this, I was lucky. Um, maybe not lucky, but I was put into a good position where it was me. And then we hired people.
Oh, okay.
And
That's awesome.
yeah, so it was, I used to tell people, now we're long beyond this, but I used to tell people like in interviews and stuff, I'd say, so if Wilsey Tool is the big aircraft carrier or the cruise ship, it takes a long time to turn around, and we are turning it around, but it takes a long time to turn. The instrument group or the instrument cell is like the helicopter on the back that just can go any direction and at a very high speed and go over to that island because there might be something cool there. And if there's not, we just come back and go back on the cruise ship, right? And really no losses. So it's really been it's been that, but there's definitely been pushback. Um, Unfortunately, it's just to people, the nature of people. There's been pushback to sort of, it's hard to explain without sounding like a crybaby or some kind of elitist or anything like that. But like okay, how come they get everything? Well, how come they get to buy a new machine? Or wow, they're doing, it's all this stuff from, oh, those guys over in the corner, which literally we were. Now it's, the corner has really grown to being a much larger corner, so it's kind of connected now. There's no, it's that most of that's largely gone, but unfortunately that was a lot of what we faced. And it's just, yeah, it's change. It's not really culture shock, but it's change. Stupid stuff like, hey, put a magnet on your machine, dude. Like, you got all these tools laying around. You got tools on this top of this door. You got tools in this little tray, Allen wrenches. Nothing's organized. It's just a disaster. Just start with a freaking magnet. Put a magnet on the side of the machine and put everything there. It's
Yeah.
so easy to take it off and just put it back on. And then start color coding your tools. Like, just make it something better. And now you can standardize that to all your machines. Well, I don't know. Yeah, we never did it that way before. Like, well, okay,
Right.
whatever, that's fine. And it's just such a difficult thing sometimes to to deal with, but it's pretty cool because now you look around and the magnet's just one example, but those magnets are everywhere in the company. They're everywhere. And just some stupid little thing like that. And I don't even think, a lot of this stuff isn't even my idea, which is the beautiful thing.
Right.
It's not my idea. The magnet would have been one of my coworkers' ideas, most likely. He said, "Hey, let's just put a magnet on the machine." It's okay, cool. Let's try it. If it doesn't work, no, we'll get rid of it. But now, yeah, it works, right?
Yeah.
So we're pretty hardcore with improvements and making things easier. And it's like, listen, man, you got a half an hour in the beginning of the day. If there's something that's bothering you or there's something that's annoying, I don't care if your machine sits. Like, that's fine. Clean up your area, make things nice, neat, organized, and you have some time to research magnets on McMaster, or just, build that thing that you want to build, to make life better, and just put that workbench on top of wheels so that we can move it out of the way to clean, or move it just because we don't like the way it's situated, or move the Bridgeport because we don't like where it is,
Yeah.
move stuff, and make it easier, make better workflow. That's just really been our MO. And that's largely the reason why I would say it is the way it is. It's, yeah, good management and kind of the right mindset and mentality towards continuous improvement. And yeah, you don't stop. So,
That's killer. That's super cool.
well, I'm glad you think so. I don't I think it's kind of cool.
I mean, I'm a big proponent of that. And like the last job I had, they were trying to do a culture shift, and I saw how poorly it could go when you
Yeah.
have people who don't understand and don't want to spend any time understanding it. And so it sounds like it's like I'm very jealous that you got to start it from the ground up, because I've
It's
tried it in the middle and it can go poorly.
It's really hard. I think if you're someone trying to do it in the middle, you need to have backing from maybe it probably not upper management, but at least your boss. They have to be bought in and agree with you. If that doesn't happen, it's just you might as well. You can keep trying because if your coworkers, really, it's for the people, right? It's for the workers. You're making your life easier. So if you guys are as a team, you're like, we want to do this, and hopefully your boss is just like, yeah, whatever, that's fine, try it. But I think it would be difficult to start in the middle, um, and maybe that's part of it because the rest of the company, not everybody's adopted it, and there's always going to be that's just the way it is. Um,
Right.
but they're sort of starting in the middle, right? Their coworkers are like, "Ooh, what's that? I don't like that magnet." Like, the night shift guy will take it off. Like,
Yep.
no, dude, you don't like. Do you know what it's for? Like, look how easy this makes your job. That's kind of, I guess, that's part of the key is just showing and demonstrating the improvement and the magnitude, the effect that it has. It's just crazy,
Yeah.
and they compound. There's these little things everywhere. So yeah, I could geek out on that for far too much time. Um, we're just talking about how I got into manufacturing, right? So
Well, you've talked about the instrument group. Let's kind of get into some of the questions because we've got a bunch, uh, a ton of them. I mean, Adam the Machinist, Firmworks, Machinist Level One, and White CNC all had questions about that Ling. Uh,
the
you,
Hobex.
yeah, Hobex system.
I don't know how you say it,
I
but I'd say
don't either.
Hobex.
Yeah, that makes sense. So
Okay,
let's get into that. How did you guys
that's
come
cool.
up with that? Let's see. Machinist Level One was talking about, is it worth setting up for high mix, low volume, or is it more for like the same part over and over and over? So let's get into how you guys came up with that, your implementation of that, whether you like it or not, all that stuff.
Yeah. So the Hobex is pretty sick. It is.
Well, and you guys are using it not as intended either, which I think
Yeah,
is kind of cool.
that's the key. Yeah, that's really what makes it special. It's outside of the box, which is like, yeah, that's also part of the MO is don't be afraid to do something that's not in a book or that's something that somebody says that'll never work. Well, yeah, it will.
Yeah.
Before you know it, it's working.
Well, and
Um,
to tag on to the end of that, don't be afraid to modify your stuff. Like I know I spent so much of my early career thinking that like vices and tools and all of this were like unchangeable things that I spent so much money on and they should
yeah,
remain the same. And then you realize one day you're like, I'll just put a hole here because it's much better for my workflow.
exactly. The fact that you spent all that money on it makes it even more necessary to change it.
Yeah,
Be like, if
exactly.
this is not doing what I need to and I spent all that money on it, I should probably make it do what I need.
Yeah,
Yeah, we took our ProtoTrack lathes and like modified the hell out of them, and we can drill 12-inch deep hole on a ProtoTrack with through spindle coolant. It's air blast, stuff like that. It's sick.
yeah.
But anyway, Hobex. Um, so yes, at emo in 2019. No, wrong year. 2021. It was last year. I'm crazy. 2021.
Yeah. I was gonna say I don't think anything happened in 2019, and it definitely didn't happen. Yeah. Anyway.
Yeah. I think there was emo in 2019 in Hanover, but anyway, emo Milano in 2021 was pretty dope because it was empty. Super cool. Um, so yeah, I checked out this Lang thing. I'm like, what the heck is that? And it's in case people don't know what it is, what it basically is to try to describe it. It's an upside down cup, pretty big cup, like a 5-inch diameter cup. That's about maybe the height of a beer bottle. It's a decent sized cup. Um, and what it does is it holds a vise inside of it. So it holds a Lang vise inside of it. And the intent is you buy this special Hobex, Lang Hobex chuck, and the hood thing will lock the vise into the chuck, and the hood comes off, and the vise remains. The hood goes into your tool. It goes into your spindle. By the way, it goes into your tool changer.
Yeah, they advertise it as like you have if you have extra tool spots in your chain magazine or something
Yeah, like
that
in
you
your
can load them up with parts.
right in your gigantic tool changer that most people don't have, and when
Yeah.
they do, that's loaded with tools. You're not going to put all these jugs full of vices in them. Sorry, Lang, but yeah, it's this huge thing that holds it holds the workpiece, and you use your tool magazine like a pallet pool. That's essentially what it is. So you got to buy all these upside down jugs and put all these vices in them, and I saw it. I'm like, wow, this is wicked cool. And I really examined it for a while and saw an opportunity to not use it the way they wanted and to just have the vices sitting on a plate on the machine table and use the jug to take the vices on the and put them like a robot arm, put them using the spindle of the machine and using the jug as the tool, go and take the vice and put it onto the chuck in the trunnion. Um, the only real need for the application is 5-axis. Otherwise, it's just overkill and doesn't make a lot of sense. So, just to
Yeah.
clarify, maybe I'm wrong. Maybe somebody can think outside the box and figure out a way there. But so yeah, we're using it in a 5-axis application. And I kind of beat myself up for a while for buying the VM3s because they're so big and we don't hardly use any of the work table. But now, guess what? Now
Yeah.
we've got. So yeah, to elaborate, we built a box, and you can see on Instagram or LinkedIn or wherever the videos around. And there, we built a box, and it holds 20 vices inside of it, 20 pallets. It's essentially we built a pallet machine, and it's wicked cool. It's been other than yesterday, actually. Today's Friday the 13th, so knock on wood. God, I hope it's not like on fire right now or completely smashed. That's like my worst nightmare. But yesterday it had some significant failures. But
Oh.
other than that, it's been good. Unfortunately, I didn't think to take a picture of the the hood with a vise inside of it, trying to load that vise on top of another vise that was already on the chuck.
Oh
So yeah,
no.
so it didn't take the vise out of the chuck.
So are you
Which
going to start probing for a vice then between?
Yep, that's what we did. So
Okay.
we're probing to make sure that the vise is in the hood in the right location, and it's hopefully a fix. I don't think that there's any real big point of failure. Like, even if the vise isn't in there, even if the whole tool holder isn't in there, because that can happen, it can pull the tool holder out of the spindle. It happened during testing,
Oh
which
my
made
god.
us, yeah, so it like yanked the tool holder out of the spindle because it didn't
So it didn't
unlock.
unlock? Yeah.
Yeah, so imagine that. And it didn't stop. So
Right.
imagine that, like
Yeah.
continuing to run with the whole tool holder jammed onto the trunnion, this giant thing, and it's just a complete destruction inside of the machine.
Whew. So to back it up a little bit, was Lang reticent to sell you vices without the hood
So Lang
or the
was
hoods
really
without the vices?
Lang was really cool about it because I was like really early on this thing, and I'm not one to really toot my own horn, but like I'm gonna toot it a little bit here about this because like this was my idea, right? I'm sure other people probably saw it and thought the same thing right away, and great, that's awesome. Great minds think alike. Um,
I could say I saw it, thought it was super cool, did not think about that at all. So
well,
you
thanks.
got it.
um, so Lang was real cool, and yeah, I was beating them up. Like I was in Italy and emailed my boss and said, "Order this." I pulled the part numbers off of the stuff at emo, like I wrote it down. I said, "Buy this. Like just do it. Trust me. Buy it." And they sent in the RFQ, and they're like, "Oh well," and this emo was in whatever it is, October, I guess. And their Lang said, "Well, it's not going to be available until February." I'm like, oh, bummer. That sucks, because I'm like ready to go because we needed automation back then, and like we really needed it now, and we kind of got it. So um, bummer. And then we placed the PO with Lang, and then they're like, oh yeah, well the lead time's actually going to be. So yeah, they said it was going to be April, and we're like, all right, well that still sucks, but we can do that. And then they're like, well, actually, it's going to be like May or June. And I'm like, dude, no, like that's not cool. So I kind of beat the guy up about it. His name is David. He's actually really cool. Lang in the United States is they're pretty cool.
Yeah, all the people are. David is who I ordered my Lang
Yeah,
stuff through.
yeah. David's nice, and so they to improve the lead time, they air freighted it, air freighted all the stuff, and we got it like first week of April, like they said. So that was cool. So it took us a while to get enough time to really get it going. I mean, building the box took me like a week.
So is that all
Designing,
80/20?
no, it's all just aluminum angle, and you'd think to make it out of 80/20, but there was too much, I didn't want to be constrained by anything, right? I really wanted it to work. I really wanted to have full control over all of the features of the design. And with 80/20, I just figured I'm not super familiar with it. I'd have to be searching through the book and, figuring out what connector to use and all this other nonsense. And there's a lead time on 80/20 as well. So we had everything that we needed. We bought some aluminum angle and, had everything in like a day.
Right. And is that
So,
just plexi on the sides and the top?
yeah, I don't know really what it is. It's just some big sheet of plastic.
Okay.
Um, it's like half-inch thick. It's super thick, but it's not a bad thing that it's thick. Gives it a little bit more durability. But the whole thing is designed to be really easy to take out. So the lid comes off, the walls come out real easy, and then the base plate, which is four pieces of aluminum fastened together, it just like slides in and out real easy, really easy to put in and out. And then you just probe a bore, probe the Z, and it's pretty sweet. So yeah, we just built it. Um, I forget what the question really was, but yeah, Lang wanting to sell it to us. No, they were totally fine with that. And they were pretty supportive of the idea because I was like, hey, can you just double check and make sure? Because this was so long ago that I was looking and handling this thing. Can you just make sure that my idea isn't totally insane, that it's just crazy? And so he did that. And they even drew up some base plates and some ideas and stuff and said, yeah, here, if you make these make yeah some details. So they
Right.
were very supportive, and I didn't even know it, but we're the first customer in the United States to get that. That's pretty cool.
That's really cool.
Kind of like first, right? So yeah, we tested it for, because I think one of the what was somebody said they wanted the juicy details, right? These are the juicy details. So it's not all rainbows and unicorns and leprechauns and golden rainbows and whatever pots of gold. Um, we were testing it. One of the main concerns was reliability of locking and unlocking the chuck. So you have to rotate this thing to get it. What Lang wants you to do is rotate it with the spindle,
Right.
do a spindle orientation.
But they want like a slow spindle orient too, because I looked at the Siemens code on their
Yes.
website, and it's like rotate and then kind of rotate back a little bit, and like
Yep.
that's what worried me when I saw your system first. Is when you were picking them up, I was like, that's a really quick spindle orient. Is that
Yeah.
we're gonna work? Like
Right. So,
apparently it does.
well, that works. Picking them up is easy because there's no torque. There's
Right.
nothing holding it against. All you're doing is dropping the shroud down to the correct height over the vise, and you're just indexing the spindle, and now it's grabbed. But putting it into the chuck, I don't know how much torque it requires to actuate, and it's a lot though. It's probably like 50 foot-pounds at least
Oh wow.
to actuate it. Yeah, like by hand, they give you like a little a little handle to stick into a hole and put it on, and it's a lot of force. So we were really concerned with that. And at first, we tried just an M19 to lock the spindle because the Haas doesn't have any kind of brake. It's just it's just a I guess that you're really just fighting against the motor, the magnets on the motors. I don't really know. I'm not really technical with that stuff, but we that's where we experienced our first failure. So we were just holding the spindle in place, using the spindle only, and um, using the C-axis on the trunnion to do the rotation. And we did that for like a day, just back and forth into the. I made a little loading plate, just little prototype, test the process, prove it out. We did that for like a whole day back and forth, and it failed. I think it failed like the next day or something, and that's when it ripped the tool holder out of the spindle. Yeah. Yeah, so it was like still stuck. I didn't get to see it, unfortunately. My coworker, he's like, "Yeah, dude, it's not going to work." So, like, oh, right. There's the first hurdle. We thought we were good, but we're not. Um so then we made a little mechanical device that is bolted onto the tool holder. So the other thing is the tool holder wasn't available yet from Lang, so it is just an arbor for a face mill. That's all that it is. Yeah, so you don't need to
Oh.
go and spend like the $600 that Lang wants you to do. Theirs is kind of special, but um, it's nothing that, if you have an EDM machine or if you have even if you have a file, you could probably make it work if you had enough time. So I wouldn't be, if you're interested in the system, just ask me or ask somebody who has it about the tool holder. And Lang will give you the drawings and everything for the tool holder. I think it's on the website. Um, anyway, we are onto phase two, which requires some kind of mechanical counteracting device against the torque to lock and unlock the chuck. So I welded this super janky thing on the side of the tool holder with like a little post, and we broke that off. I don't know. First we broke it off from spindle orientation. Like we just broke it off a bunch of times. Broke it off, putting the tool away into the tool changer, cracked and whacked against the sheet metal and just broke it off. So, but eventually we got it, and we put like, there's the little tooling block. We were going to make like a tooling block, right? But now we have this giant thing hanging off of the spindle nose, which now changes so many of the clearances potentially that we've already kind of designed into the system. And my coworker was like, "Well, why don't we just um, put a screw in there, put a cap screw in?" So we just wound a 1032 cap screw into the bottom of the spindle, where there's two little holes for the tooling block into the bottom of the spindle. So now we have a little screw sticking out to act as something to push on. So it's like a really, 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 really tiny tooling block, just a little protrusion out the bottom of the spindle.
Huh.
And if yeah, I'll have to post a more updated video because I don't think this is on any videos that I posted. But we built a little thing with like a spring plunger with an angled ramp on it, so the spindle can go all the way around the tooling block and it'll slip underneath, and then you can just rotate in one direction, in the other direction it'll hit and it'll catch. So again, not my idea, coworker. um, so yeah, it was pretty cool. That's working really well. We built a much more purposeful one that bolts onto the tool holder. It's not welded and cobbled and janky together. It's pretty legit. And so yeah, it was working really well. The first night, so we had to come up with a program, like a main program to run this thing, which wasn't too difficult. If you're interested in details, just ask. But it's pretty basic, just using variables and stuff and some thought. You got to think about some of this stuff to keep it simple.
So are you still using the C axis to lock with that tooling block?
Right. We're still using the C axis to lock. Yeah.
Okay.
And that's been very reliable. Mostly reliable. So the first night of we're like, all right, cool. We're gonna do it. We're just gonna send it, right? Like we're there. Um, and we came back the next day. Like we had the box fully loaded. Well, we only had 15 vices at the time. We have room for 20, but we had 15 vices loaded up, and which is like pretty cool. It's a lot of runtime. And
Yeah.
came back in the next day, and it only went for 3, and I'm like, what the heck? So there was an M30 in the program after the third vice. We forgot to take the
Oh.
M30 out. It's like, oh god, it's a crusher. It's a crusher. So it was probably a good thing. Like something bad probably would have happened if it wasn't in there. It is Friday the 13th, so we have to try to act superstitious. So, uh, so yeah, the next day it ran for 14 and a half hours. That was pretty cool. And it
Jeez.
stopped on a broken tool, which was mostly bad programming. Um, it's cool because you learn a lot of things from having this, which is great because it's preparing for the next level of automation, right? Um, so in Fusion, guessing a lot of people use Fusion who are listening. Do you use Fusion?
I do. Yeah.
Yeah. Okay. So, like, do you know what the tool was doing was it was rest roughing, 3D adaptive rest material, and pretty sure the tools before it were kind of tired. Pretty sure they were probably deflecting. Pretty sure there was way more material than Fusion thought for this little. It's like I think it was a 3 millimeter or 4 millimeter end mill. Um, long length of cut. So they're 12 millimeter, 16 millimeter long with, no room for chips. It's basically a dynamic tool.
Okay.
Anyway, in Fusion, under rest rough, or under rest machining, and the like, where it talks about machining the cusps and
Right.
stuff.
Ignore cusps and then the additional offset or whatever. Ignore
Yeah,
die
and
offset or
right.
whatever.
So like stupid stuff that a lot of people I'm sure know. If you do, what's the one? Machine cusps, right? Machine the cusps. If you
Hmm.
do that and put an offset in, the tool's going to stay further away. And I just never really had to learn that. So I'm sure if you needed to, you would have learned it too. But if you want your tool to give a little extra time and cut a little air on the simulation, that's how you do it. So kind of cool. That was one of the first things that we learned.
Well, and it's fairly poorly explained. Like, I mean,
It
Fusion
it
has those
is.
those great dialogue boxes, but you look at that one, you're like, wow, I still have no idea what's going on. Cool,
Yeah, and
thanks.
then you like read it again and you're like, all right, slow down. Like word for word, I still don't know. Yeah.
Yeah, I end up like just monkeying with the values until I see the change that I want. I'm like, cool, okay, I'll remember this for the next time, and then I don't remember it for next time.
Yeah, exactly. Exactly. So yeah, and then like I don't even know at this point. I stopped. I was posting those stories every day of like coming in and seeing it with a box full of parts and the green lights flashing and no problems and the runtime and stuff. And I stopped doing that, but just because I thought it would get kind of annoying, so I stopped being annoying. And but for the first 6 days, it just ran and ran full loads, and we probably I don't know the exact number of different parts that we did, probably in the neighborhood of 10 different components that we ran unattended. So the question regarding the high mix, low volume, we are high mix, low volume. That is what we are built for. And this is not as good as a machine with a lot of tools and a lot of pallets and a little bit more on the automation side as far as actually planning and scheduling your work. But this is pretty darn good for the cost of the system if you're willing to invest the upfront into just getting it going on your machine. So yeah, we've gotten like the first 4 nights we got over 40 hours unattended,
That's killer. That's
right?
amazing.
Yeah, it's pretty cool. So, but right now it's probably sitting there idle. I didn't have anything ready actually, so it eats. You got to feed automation is like a whole thing.
Yeah.
So it's not full. It's not loaded right now, but it will be tomorrow. So
So so how does that lid work? Because I've seen where like the shield goes down in it and then moves it over to the vise that you're currently working on. But
yeah,
at some point, doesn't the lid hit the front door?
yeah. So that was one of the big thinking points. No, it doesn't because the table moves.
Of course.
So
Okay,
the lid stays stationary relative to the spindle. The lid doesn't move relative to the spindle.
that makes sense. Yes.
Right, right. It's a weird one. It's a weird one for sure.
Yeah.
But yeah, essentially the blue shroud goes between what I call the handlebars, the two bars that are going crossways, and it goes between there, opens it up to wherever it needs to, and in the y-axis, and then moves in the x-axis to go and pick up the vise. And that's just a
I love that.
macro.
Like that's
Yeah,
so smart because then there's no chips in there. Because when I first saw you were using it, I don't think I saw the door, and I was like, oh man, that's like a recipe for disaster. There's gonna be chips everywhere. And then I saw the lid, and I was like, oh, he thought of everything. Like that's great.
yeah. Thank you. It again, if I do say so myself, I think it's relatively well thought out for like version one. I don't have a lot to change other than not making some of the machining mistakes that I did, which just don't look good, but it's totally functional. Um, yeah, so it's a really, I mean, it's really cool and it's kind of novel. It's new and exciting. So it'll eventually get boring, and we'll pass it off to somebody who thinks it's cool, at the shop. But yeah, it's real good. Probing is another thing that had to get better at. So it's just stuff you don't need to know because it's done for you. Like Fusion just does it, right?
Right.
So we had to do these parts that are pretty tight. Done some pretty. That's the other thing is we've done some pretty tight tolerance parts on it, which is a little sketchy. So the first part we did that was close has little posts. They're 2 millimeter diameter, 2 millimeters tall. So the tolerance on the diameter is plus or minus 7 microns or less than 3/10.
Yeah.
So on a Haas, you start to take into account the actual ability for the machine to cut a circle. And when you make it really small, it's like having, a tenth of run out on a 2000s diameter end mill. It's going to destroy it. So you have, 3/10 of out around. There's half your tolerance on this little tiny post. That's like, it just sticks out like a sore thumb. So yeah, some of those parts probably aren't really perfect, but we're going to, maybe I didn't say that in public, but
Hey,
um,
you never know until they hit QC. They could be perfect.
yeah.
Uh,
Yeah, the CMM says they're good. Okay, so if the
uh,
CMM says they're good, then they're definitely good.
yeah, there's
Um,
no way to program a CMM to tell it what you want, or to have it to tell
I
you what
didn't
you want.
program it. Okay, I didn't even program it. So this quality says they're good. So we're in
There
good
you go.
shape.
Yeah, no, but that like
Um,
gets into like you're like oh, tool choice because you want a smaller end mill so you can actually drive a circle versus like a bigger tool that might be more stout, but like then you're interpolating less of the circle and you have more
yeah,
accuracy issues.
exactly.
Yeah,
Yeah, so we ended up with a 2 millimeter diameter end mill, which just so happens to be one of our standard tools. And it's not ideal for finishing, right? So I need to kind of improve on that. It's a 3 flute end mill. We use a lot of 3 flute and 4 flute end mills. We don't get really too crazy with the
really,
high flute count. Yeah.
because you're machining not easy materials.
Yeah, and because they're not easy, they don't respond very well to. This is kind of one of my theories that I've learned, or yeah, that sounds weird, but this is one of my hypotheses. These tough materials don't really respond well to things, right? Like, how do I say it? Why would you want to use some tool that is gonna push on the material even harder when when the material is pushing back on that tool even like just as hard? Like, so when I think about these high flute count end mills, that's that many more chips being made at once, right? Like that's that many
Right.
more flutes in the cut.
The tool
And when
pressure
you
goes up significantly.
sure, it's significant. And when you have parts, like a lot of our parts come out of rectangle stock. And if you have a piece of stock that's a half an inch by 2 inches in cross section and maybe 4 inches long, and you hold that in a vise that's a let's say a 2 inches wide vise, and you try to like stand that up and go and wrap around those corners, you're gonna break off your unless you're taking like a 0.05% step over and just rubbing everything, like
Right.
it's gonna grab, right?
Yeah,
It's
you're gonna yoink that thing out of vice real
yeah.
quick.
So there's obviously different strategies, but part of our system or part of what we've created has been like, how can we be as how can we be as diverse as possible and really standardize stuff. So standardization has been huge with where we're at. And if you want to do high mix, low volume, you have to understand where all the common denominators are. So there's if there aren't any, you got to look harder. Like there's always something that you can standardize. If you got a bunch of parts and it's a family of parts and you're like, "Oh, I got to just run 10 of each and this one's 1 inch 850 and this one's 1 inch 750 and this one's 1 inch 550 and this one's 1 inch 900, right? And this one's 1 inch 200. Well, just make them all out of 2 inch stock,
Right.
right? And now your programming just became simpler. Your material handling just became simpler. Unless it's made out of gold, you're not going to suffer any real costs, right? Um, it's still only 2 inches long, so a lot of people don't maybe think that way, and that's fine. It's just the way it is. But same with tools. Like you give up. You have to give a little bit. Like we're not gonna use that high flute count because maybe it doesn't work, or maybe we are gonna use it because the other one doesn't work, or vice versa, right? It all depends on the type of work you do.
Yeah.
If we were doing vice work on the table, yeah, high flute count all the way because it's super stable.
Yeah.
But
So what tools do you standardize on? Like what brand of three flute have you found stands up well to all these crazy materials?
the
Because
rabbit
like
hole is has just begun to open, sir. Uh, um, so to preface that question, we cut instrument materials. So those are 17.4 is the bread and butter.
of course.
H900 is the condition, and that hardness is it comes in about 46, 47 Rockwell. But it cuts really nice. You talk to anybody like, oh, 17.4, yeah, butter, cool. Which
It's
is,
my favorite stainless steel out there by
yeah.
far.
And a lot of people say, well, it cuts so much better heat treated, but I think it's because everybody machines it heat treated. A lot of people don't. Like, do you machine it soft ever or annealed?
No, I just buy it heat treated because I've always been told that too, and it cuts
Mm-hmm.
so well heat treated that why would I try anything else?
Yeah, exactly. It depends what you're doing, but in my experience, you'll get better tool life on heat treated. I mean, it just makes sense,
Right.
right? You want annealed or you want 46 Rockwell?
I think a lot of it too is that most of the parts I've made from it are relatively tight tolerance. I mean, not
R-
7 micron, but whatever. But it's like I don't want that thing to move after heat treat, so I'm just gonna deal with the
sure.
tool life and machine it heat treated and call it a day.
Yeah, and I don't blame you, and it saves a step.
Yeah.
So we have all of our 17.4 is already heat treated. But anyway, I was talking about the materials. 17.4 is the majority of what we do. We also throw in some 465 and 455. Uh, those are those are mostly like American materials. They're made by a carpenter in Reading, the Cartech. So it's a carpenter thing. And in heat treated state, those are closer to like 51.
Ooh,
52, and they're tough. So
ouch.
it's a totally different thing. And so now you throw in that into the mix, and those you can't run the same speeds and feeds, like not even close, not even for like one or two parts. Like you'll blow stuff up. So going back to the tool question, and we do a decent amount of Nitronic 60, not a lot, but
Ooh,
probably about as much Nitronic 60 as we do 465. So the
Nitronic is no
tools,
fun. I haven't done much, but the little I've done, I did not enjoy.
yeah, it's yeah, it's really I guess it's a good topic because like I don't know, we haven't really struggled with it so much, Nitronic. I kind of equate it to like kind of nasty 304, or maybe what it would be like to machine like what is it, 347, or some of those 321, like some of those worse stainless, real gummy. It's just kind of abrasive and gummy. It's not hard, but it
Right.
takes a lot of force to cut it, right? It takes a lot of force to just shear that chip off. So back to the tools. The three flute tools are, we are a big fan of Micron.
Oh, really? Okay.
Yeah, yeah.
I haven't used much of their
Micron,
tooling, but they've got some really interesting stuff. Like their crazy drills, crazy flex drill, whatever the flexible
sure.
carbide drill is. That
Yeah,
thing's nuts.
crazy drill flex.
Yeah.
Yeah. We haven't used that. I guess if you need to drill a wicked deep hole that's small, it works. Um, so that's pretty cool. But they have their end mills are gnarly,
Okay.
and their speeds and feeds. Anybody who uses them knows it's legit. Like their book speeds and feeds are legit. You can take them to the bank, kind of like Freza. Freza has really good speeds and feeds, and yeah, they might seem slow. Some of the stuff might seem slow, but it's reliable. Like it's dialed.
Right.
You get good tool life. But yeah, Micron's pretty cool. Mitsubishi, anything VQ. If you cut titanium, um, a VQ MHZV is the three flute. VQ MHV is four flute. Like those tools are very good. They're good. The Micron is really good though. We actually just tested on one of the parts. We actually just tested a Goering micro diver. So the Goering diver, but the micro.
Hmm.
Uh, Actually, they're pretty cool. They have coolant through the shank, so does Micron.
Oh,
So
cool.
it's like coming through the shank. Yeah, so it stays stronger. Um, and it really gets to the tool. But the Micron lasted 2.5 hours in cut, and compared to the Goering was only like 58 minutes. So um,
I'm gonna have
it's
to
kind of
get
cool
these
to.
part numbers from you because I do more and more titanium as of late, and
Oh, okay,
I don't get terrible tool life. Like I will say like not to shit too much on helical, but their like 7 flute rougher has been amazing for me
sure,
for
yeah,
titanium. Like I don't know, I've got hours and hours in the cut on this one that I'm continuing to use, and I threw it in. I used one back in the machine to cut some 304 today, and it ran fine. And then I'm sure I'll throw it in to
nice.
make some 17.4 parts, and it'll be fine. Like it really just does not die. But
Yeah. So do
I,
you?
I I'd love some other recommendations for sure.
Well, yeah. So one of the nice things is that I'm not paying the bill for tooling, because this stuff is like it's the I know there's better tools out there, but these are like the best ones I can find, and money is basically no object. So most people, if you can justify it because it just shreds all day long and doesn't break, that's total justification. Like process reliability, good tools is number one. Like you could have the fastest dragster in the world, but if you don't have good tires on it, you're never going to get off the line. So like
Yeah.
where the rubber meets the road in our condition is the tool. So for
Well,
us,
like
it's always been good tooling. Like we run Power Grip on a Haas, right? Not a lot of people bought Power Grip for their Haas.
Right.
We did, and
Yeah.
it's no regrets. It's sick.
Yeah. No,
Um,
my business partner and I kind of, one of our foundational principles of the company has always been to invest in the best tooling possible, because at the end of the day, too, like, yeah, I might have spent double on an end mill, but if it means that
yeah,
I don't have to dial it in and it cuts a perfect part on the first thing,
yep,
that's time. Like, that's money right there.
exactly. So do you track your tool life?
No, because I cut mostly aluminum. So it's,
Right. It's kind
I
of, it's
replace
just,
tools when they start streaking, or I'm like, the finish could be better. It's not like
okay.
they don't wear out really.
Okay. Yeah. I guess, yeah. Um, I would say that if you didn't cut aluminum and you didn't track your tool life, it's been one of those things where we started doing it maybe like a year and a half ago. And anytime we change a tool, a standard tool, so we have the Haas 50 tool changer, which is pretty cool. So 35 are standards. And for anybody who doesn't know what that means, it just means that those tools stay in the machine always. They do not change. If they're, we have changed them. We've changed. So like when I say they don't change, you don't change the holder, you don't change the stick out, you don't change any of that. You don't change it. You don't put a tool with a shorter length of cut, right? You want it to be cross compatible, like playing a PlayStation 3 game on a PlayStation 4 or whatever.
Yeah.
You need to be able to do that. We need to be able to make games that'll play on any platform.
Well,
So
you're
we need to be able
limiting
to
variability. Like, that,
exactly.
like, as you're back to leveling the lathe. Like, part of being a good machinist is knowing how far to take the process back to diagnose stuff. And it's like, if I don't
Yeah.
have to talk about my tool holders, I don't have to talk about my tools. I now know
Right.
where to start from.
Right. And this also is part of, that's a good point. This, and it's also part of standardization. So we have it standardized. So it's just like, it is the way it is. And it's built into our tool library on Fusion, and it's in our programs on Fusion. So we run templates. So if you've ever seen the Rob Lockwood video from Autodesk University of the container method when he does the template demo,
Mhm.
that hit home pretty hard. And we do that like hardcore. So we have a bunch of toolpaths, and I'm sure other people out there are doing this too. Do you do that at all?
I don't yet. We are
It's worth
on the
it.
cusp of doing a lot of that. So up until November of last year, I was not full time, and
Right,
so
right.
I was kind of, man. I had like 3 4 hours a day, maybe. If I was lucky, if I didn't have other things to do, like with my wife or whatever. But
Uh
like,
huh.
it was kind of do the most I possibly could while I was there and get the most work out. And like, if I was lucky, I maybe had a night a month that I could work on process stuff. But now
Oh,
that I'm there
wow.
full time, it's like,
You were just hustling otherwise.
yeah, yeah, exactly. So now I'm like, I talked about it last episode. We're getting paperless parts to kind of do the quoting side or help us do the quoting side. I'm going to get all of our posts styled in the next month or so. We're kind of working on some fourth axis trunnion workflows to really dial in all of these one-off stuff with side ops and all that. And
Yeah,
that's my goal
that's
for this
cool.
year, is to kind of get things really dialed so that Brad and I can really just knock parts out left and right.
If you need any help or anything, or you have questions, just feel free. I can maybe help with the whole template thing because we've been doing it for a while, and we've got a handful of programmers, so it's pretty cool. You all use these toolpaths that all have the same step overs, right? So like I program the same as you program in theory. Our cuts are the same. So
Right.
now you're standardizing cuts. So now you can track tool life because you in theory are always doing the same cut. Yeah, sure, stability changes, rigidity changes, all that stuff changes. Maybe the material changes, but for us, we're lucky. Even for you, like yeah, aluminum. I guess the tools don't wear out, but if the material is relatively the same, you can start to track stuff, and it just prepares you for that, making that jump for the next level of into automation. So yeah, I could go on and on and on about tools, but the best milling tools that we have found on the small scale has been Micron by a long way. They
Okay.
are also by far the most expensive. So like a 3 millimeter end mill is like, I'm probably going to get the price wrong, but I think it's like $130 or $140 for a 3 millimeter end mill, 2.5 times D length of cut. But that tool will run in titanium for probably, at crazy speeds and feeds, especially if you have RPM, it will remove a lot of material and will pay you back like in a day, right? Because it's just so reliable. The best tools that we have found for, and again, this is all largely based on 17.4. The best tools that we have found for bigger stuff has been actually Imugi.
Oh,
The
really?
Imugi, yeah. So our roughing tool, we have a 10 millimeter, 8 millimeter, and 6 millimeter, and those are like our rough tools. We never finish with them. They're just 4 flute, 5 flute. We've tried 6 flute. They've been the main roughing tools that we experiment with. We also have a 1/2 inch end mill. That's a 4 times D that stays in the machine all the time, and that gets used a lot. And that's sort of how we discovered the Imugi. So we started with that. The tool is a Imugi Tinox, Tinox trochoidal. So it's gold and it has chip splitters and it's got a central coolant channel, and they're pretty good. So for 17.4, it just seems to hold up like crazy good. Um, like we'll get on that 1/2 inch tool, we'll get like 7 hours in the cut. And it's on a Haas. It's on
Jeez.
a Haas, okay? So it's not real crazy, but like our parameters on that are, I'm going off the top of my head, I think it's like 180 meters cutting speed. Sorry, I'm metric. So times it by 3.82 or whatever. And, normal step over, whatever that would be, not a lot, 7.5% or something. And the feed rate's actually kind of low, like 0.08 millimeters per tooth. It's a 5 flute cutter, but it removes a lot of material, and yeah, it lasts for 7 hours, and it comes out, it's all chunky and torn up. But we put that tool, same tool type, into our roughing tool for 10 millimeter and a 2 times D. And now we almost doubled our tool life. And that's from trying like other pretty good tools like Sandvik. We would use this Sandvik Coral Mill Plura HD with the radial coolant coming out of the flutes. It's a pretty fancy tool. That's like a $200 end mill or $180 end mill. And it like doubled the tool life, and it's cheaper. Um, we tried like Mitsubishi Coolstar, which is a really good tool, but it's not so good for 17.4. I think it's more for like titanium and stuff, and that's just stupid expensive. So anyway, if you guys are going to go and run 17.4, if I had to do it again, there might be a better tool. If you know a better tool than that, like be my guest. I really want to hear what it is because I'm always looking to try something better. Um, but yeah, to be able to double our tool life is pretty cool. I don't think we're missing anything. Like I think that is the only thing that changed, right? When you start to do these scientific type of collecting data and stuff, you got to watch. Did we change something else? Like, did the cutting speed go down, or who knows, right? So anyway, yeah, standardization and tools are sweet, man. Tools are the best.
It's a lot of fun for sure.
Uh huh.
Uh, okay, so Josh from NH Micro had some
Uh
great
huh.
questions that I wanted to get to. Said, what excited you about the trade 5 years ago, and what excites you now?
Um, what excited it 5 years ago?
Mm-hmm.
Everything was cool. So I was just really interested in that was sort of when I was opening my eyes towards some of these lean concepts. Uh, the the continuous improvement was part of it, but also flow and one piece flow, stuff like that. Um, Spent a lot of time really trying to get to that point and haven't given up, but have sort of had some realizations that one piece flow is probably something that is not desirable in most manufacturing situations. It can create yeah, I don't want to get too deep into that, but don't go crazy trying to get it because it might not be worth it in your application. But it's fun to think about, like, how could we do it? But you need a system. I guess that's the realization, is you really need a system and like a ERP or something that is really good at that. And most ERPs that I've seen, I've very little experience with ERPs, but we use JobBoss. It doesn't facilitate one piece flow.
Oh
If
man,
any of
job
you
boss.
guys, yeah, if anybody's using JobBoss, and is like using it in a really cool way that's lean and highly effective at low volumes and very short lead time and high throughput, let me know because I want to know what we're doing wrong. I'm not really don't really have my hands in it, but I know there's a lot that we're missing. But anyway, that was, I guess, one thing from 5 years ago.
Okay.
And just the nature of, like, I sort of had a really great opportunity, and we were 5 years ago is probably when we were just stepping into like Fusion and getting Cam, and my boss bought like the $60 laptop off Craigslist from some random guy, right? And we were using Fusion on that and programming some pretty cool parts for our one customer that were prototypes, like actual real prototypes, and trying out, some of these tools on the knee mill. And we started using Mitsubishi more. And the guys who run the Willemans at our shop, they're really the ones that sort of found Mitsubishi, because Willeman uses them a lot. But yeah, we were just trying stuff and continuously learning. And probably around that time, we started doing the deep hole drilling on the ProTrack lathe. So we were running, yeah, Mitsubishi drills, and now we're using like Micron drills on a ProTrack,
Proto
right?
track.
Yeah, and drilling like some pretty straight, pretty deep holes, doing some pretty cool parts. Um,
That's awesome.
yeah, stuff that's like people see it and go, "Wow, yeah, that's should never be doing that."
Right. So then what about
Uh,
now? What excites you now? I mean, it seems the one
yeah,
reason I reached out to you is that it seems like, no matter what post I go to or what story I go to, you are nerding out on something new. And like, I love talking to people
yeah,
in the industry who make it an effort to not stagnate.
right. Yeah, I guess I'm clearly a nerd. So for a while there, not a lot was exciting me. Kind of bored, if I'm being honest. The the drag of it's not a drag, and yeah, it kind of probably comes out wrong when I say that, but dealing with kind of managing people is a lot, and it kind of takes the fun out of the job. My job is first a machinist, but it was morphing into it really it is a managerial type of role, right? I oversee a group of guys. Um, they I'm responsible for them,
Right.
so can be a drag when there's underperformers, when there's negative attitudes that can be hard to come back from. And it just takes away from the fun of the job. So for a while, things are better now, which is good. But for a while, it was like tough to really want to put in the extra effort and do the cool stuff because it was like it was a grind. We were
Mhm.
getting the same parts. We're really just at this point, a lot of the work is repeat. There's not a lot of, I mean, there's still a ton of new stuff, but it's not as much. Like everything's new when it's new, right? When you're doing something for the first time, everything is new.
Right.
So it was cool because it's actually nice now. A lot of it's repeat, and especially now that we have this Hobex automation thing, it's already parts that are proved out. So like that's partly why we've been successful with it. It's just been running because we have good data. We know what we're doing, kind of. Um, So now what's exciting, I guess, I mean, if you can't tell that Lang thing, the Hobex has been exciting,
Oh yeah.
definitely exciting. Um, you can't really say enough about that. It's new. It's something if you don't have automation and you get it, it's like, wow, this is cool. I always joked with my bosses, and I would say, hey, there's going to be a time when I'm sitting in here talking to you guys in the conference room and we're, doing whatever. And the machines, it'd be nice if the machine was running. And now I said to them the last time, I said, well, hey, remember all those times when we joked about the machine being running when I'm sitting here and talking to you guys? Well, guess what? It's
It
running.
is. Yeah.
Yeah, it's running now. So that was kind of cool to say that for the first time. Proud little win moment. So yeah, that, and looking forward to just going to IMTS, and we're going to got invited kind of not really randomly, but GF invited me and my one coworker to go to Sonoma to TRD and check out the factory and wherever they build the engines and stuff, and go to a NASCAR race and do stuff like that. So that's in the beginning of June. Hopefully, I can post some pictures or something from that. That'll be pretty sick.
That's really cool.
Yeah,
Do you guys
because
have any GF machines? You must.
we don't have any GF. We do have like Charmy and
Oh, okay.
the old
Yeah.
school GF. Yeah, so it's not really. I never really broadcasted it, but we did buy a Kern.
I was,
We are
yeah. I was
yeah,
going to bring that up and what's new because that's super exciting.
yeah. So we're going to be taking delivery sometime at the end of the year or beginning of 2023. So we didn't get the HD. We got the Vario, which should be cool with a compact 80.
I think you'll be more than happy with that.
Yeah, I think so too. I could go on and on about that whole decision process, but um, I think we made a good decision. It's not a real beefy machine, but it kind of is. They're pretty stout, but yeah, there's going to be a bigger machine coming in the near future for us. Hopefully, a Hermla or a GF or something. So, really like the what Hermla offers, but I think GF is kind of cool with the automation from behind.
Yeah. Yeah, I really like
So
the integrated like into the casting and everything.
yeah.
It's very
So
cool.
right. So gonna kind of look at that a little bit and see what they got, you know. But yeah, the Kern's cool, and I'll probably never live it down that that's my last name on the machine. But yeah,
That's
gonna
pretty
catch
cool. Yeah.
gonna catch a lot of crap for that. Like, oh, you bought a machine with your last name on it. Yeah, that's great. Yeah,
How original.
right. Yeah,
Well,
Mr. Kern.
the last question I wanted to touch on was I think a joke question from Mickey Six Gear, but talking about how fast eyebrows grow back. And I wanted to get into that story because I saw the picture of it and I was like, oh shit.
Uh, yeah. So thanks for the question, Michael. Yeah. How fast do the eyebrows grow back? I don't know. How fast does the hair grow back and the nostril hairs and everything. So,
So how did that happen? I guess what happened and then how did it
right.
happen?
So we got our Haas's in 2019. Yeah, 2019. And one of the first kind of cool projects that we did was a special plate for, it was a custom plate. So a custom implant, which is, that's getting pretty special now. The only custom implants I've done have been for people who really, really needed them. So this one was for somebody who really needed it. They had like a crazy, I forget all the medical terms now, but they had scoliosis like real bad. And, and they have, I think it actually on the Instagram thing that you posted, I
Mhm.
think that plate was on it.
Yeah. Okay.
Yeah. Yeah. So that little piece that's attached to a 3D print of the spine, you could see how twisted up their spine was. And so we had this plate. We knew it was coming. We didn't even get the PO or anything, but the customer sent us models and started making them. And we're basically proving out the process and working through it, trying to really just, hit this one out of the park. So basically, they sent us the PO and sent us the final drawings and stuff, and we shipped a job in like 2 days or something like that.
Oh wow.
So yeah, so it was like super urgent. Patient really needs it. Uh, Kind of cool when you're that close to impacting someone's life for the better.
Definitely.
But anyway, I'm there. We had the machines probably for like 2 months, maybe something like that. Probably about that. And so the plate's titanium. And I was doing some roughing. And essentially what happened was I just messed up. I mean, obviously, eyebrows and hair burned off. So what happened was I made a change to the toolpath. Thank you, Fusion. So I selected shaft and holder and rest machining or something like that, and it like completely failed. It glitched out hard and it like crashed. So I didn't see it. I didn't even
Oh
see it.
no.
And I simulated it, which I always do, right? You always simulate before you just make sure there's nothing bad. And I did that, and there was like a giant block of red on the simulation, right? It should be green, everything's good, red is bad. So the red was like really bad red. Like not just like tool going through the part, like holder going through the part. Badness. And I didn't see it.
Oh
Like for
no.
whatever reason, I was blind to this giant block of red, and I'm just like, oh, cool. Post it, get it back on the machine. I was like super amped up trying to make this plate, and well, I posted it, and it went, and it just. So this was one of those Sandvik, or no, maybe I don't remember what tool it was, but it's a tool with radial coolant, and we don't run coolant, we run oil. So it's like misting the whole cabinet of the machine or cabin or whatever it is. The whole enclosure is full of mist at this point. And I'm like, hit the button, totally just, got my walk, I'm like
Right.
confident, right?
Yeah.
Which you got to be confident if you want to be good at this. But
Hmm.
I was confident, and it just, the holder, I kid you not, the holder just smashed right into the part, spinning at 8,000 RPM or whatever. And steel mixed with titanium is different than carbide mixed with titanium. Steel and with titanium, like friction just gets crazy and it gets white hot and it catches things on fire. So the machine caught on fire. I wish we had cameras in the building. It would be epic. It would be like one of those crazy machining videos that you see, like, don't do this. Um, the doors were closed and everything, right? But my face was in front of like where the doors close,
Hmm.
the gap or the seam. And this thing fireballed so bad. Like flames were shooting out of everywhere. That's what people say. Um, they shot out of the door crack and like into my face and burned my. Thank God I had my glasses on. If I didn't have glasses on, I might have had like permanently damaged eyes
Oh,
from the fire because like my whole face was burned. My not really burned. Like my skin was fine. It just felt like I rubbed my face in habanero peppers or something. Um, but yeah, like out of the chip conveyor, like stuff was blown. There were papers on the workbench behind me, blown onto the floor. Like stuff was blown everywhere from this crazy like fire explosion.
oh my
It was
gosh.
insane.
Whew.
That was the worst. That was definitely the worst crash I ever did as far as dramatic. It wasn't a bad crash, right? If it was 17.4, it would have been no big deal.
Right.
Like, oops, I messed up, keep going. But it's kind of a lesson that in titanium, you don't really mess around with rubbing. Like, if you're going to rub a tool holder and you're just like, I'll just get through it. Like, no, don't do that.
Right.
Don't rub
It's
it.
a bad idea.
Yeah. Yeah. It probably won't end really that great. So,
So you guys must have fire suppression on all your machines? Or
yeah, no, we don't. The first machine we got fire suppression on. So we have fire suppression on our Willemins, and it took a while. It's crazy, right? Like you're running these things, lights out over the weekend, nobody's here. You're going to burn a building down.
yeah.
Like the
Yeah.
sprinklers are going to go off. And then what? because you didn't want to buy fire suppression. So the Williman guys were so persistent, and we finally got fire suppression. It's not even that expensive.
No, fire
So
trace
it's
is
like,
like well worth. I mean, like
yeah,
it's cheap insurance.
exactly. I think it's like $6,000 to install it on a Williman,
Yeah.
and you're running, medical device unattended. Yeah. So anyway, but other than that, we didn't have it on any machines in the shop. So our Haas mills, like, no, we only just got it when we installed the Hobex. We installed Firetrace.
Oh, thank goodness. So how'd you put it out? You had a
It
fire
just went
support.
out.
Oh wow.
It went.
Okay.
It was just all the mist. So all the mist inside of the
Went up.
cabinet exploded,
Right.
basically like a fireball. Yeah, it was kind of crazy.
That's
But it was,
terrifying.
yeah. And then I'm like, meh, like, all right, because the building's full of smoke, so everybody's standing outside, right? You got the garage doors wide open and fans going, trying to blow all the smoke out, you know. Um, and I just like went and got some pizza or something. They're like, "Are you okay?" I'm like, "No, I'm good. I'm good." Like, they're like, "You should go look in the mirror," and that's when I took a picture of myself. It was like, wow,
Oh,
my yeah, my hair was like all singed around my hair, everything. It's pretty funny. Uh, and then I did end up going. I came back. I'm like, man, my face like really hurts, and I was thinking I should probably just go to get checked out, like in case something happens to me. So yeah, I went to urgent care, which I hardly ever do, but this was one of those times when I did. So
that's like that's a fair explanation for going to urgent care.
that's I don't know how long it took for the eyebrows to grow back, but they eventually did grow back. Yeah. So
Oh
yeah, it's
boy.
pretty cool. So anyway,
Well,
that's that.
I know we're running a little long on time.
Yeah, it's
Uh,
fine. I got time.
all right. Well, instead of shop news and new things, let's quickly talk about why you guys chose a Kern then, because that is your new
Okay.
thing. I think that
Yeah.
that's kind of an important decision that people see. Grimsmo with a Kern, they see like all the options that are out there. Why did you guys choose one?
Yeah, so that's a pretty loaded question, but I can keep I guess there's probably some simple points. My brain doesn't work quickly
Well,
enough to get to
what did you
them, but
cross shop? I guess is the first question. Like, what were the other options?
yeah. Well, we looked at basically everything. Um, we looked at everything except for DMG Mori, just because of the service that I've heard about.
Yeah,
So,
that would make me a little nervous as well.
yeah, I don't know. It was just what I was told. I really didn't think that even if we found one that we thought would have worked really well, I don't think that the higher ups would have bought it. So, so the major concern for me was I was always stuck. I'm like, man, we're cutting all these big parts. Like, where's a lot of material removal. We, we might load a block. Some of the biggest blocks that we cut an instrument out of is going to be like 2 inch by 2 inch by whatever long, 6 inches long, 17.4 H900, which for a lot of you guys, it's not that big, but like that's a decent sized chunk of steel.
Right.
Decent. So when you look at that and you say HSK 40 in the same sentence, it's kind of confusing and concerning. And Kern really checked a lot of boxes early on. I'm like, well, this is pretty cool machine, very small, like good tools, good amount of tools, plays well with the Aroa automation. Um, yeah, small footprint, accurate, even though we don't really need the accuracy. But at that time, they weren't really that well. They weren't nearly as well known as they are now. That's for sure. So it was kind of a tough sell, and I couldn't really sell it to myself. So we had basically everybody come in. So like Okuma considered the MU4000V, but I don't know, it's just kind of big for us. Like clearances were a big thing. I didn't want to go too big on the table because I wanted to keep our standard tools that we were already using in the Haas. I didn't really want to like change gauge lengths. I didn't want to change a lot of stuff. I didn't want to change a lot of fixturing. I really kind of wanted to keep it the same if we could, um, just for that cross compatibility and transferability, right? I don't want to have to change every program because this machine is so much different. So the Akuma was okay. Hermela, however you say it, Hermela, um, they're pretty cool.
They're pretty
I
big though.
really, 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 really like their machines, and I really like their company. Um, I like their philosophy. I like that all their machines are the same. They're just bigger or smaller. Really cool, and I really like their automation. Their RS1 is like the coolest automation, and probably, I don't know, the most highly developed for a not custom solution.
Is
Although
that the
they
one
will
that
tell
like
you,
pick work holding and material and like load
yep,
them all individually and stuff?
correct. So you could load pallets. You could do whatever you want. You could load pallets. So if you wanted to load a row of pallets, parts on pallets, you could do that. If you wanted to load a vise, um, with a programmable jaws stroke, you could do that, and then you could, you know, so on that one vise, you could be loading stock, and once you standardize your stock, and you could have a tray of stock that's got 20 pieces of stock in it, and you could run 20 different programs that all use that same stock.
Right.
So like again, standardization is so cool. So the RS1, yeah, the RS1's really sick, and they actually had it on a C250 at emo. Probably a lot of people saw it on Saunders, his video. Um, so we were checking that out a lot, and I really wanted one, but they're very expensive. Hermela is like a super expensive machine for whatever crazy reason. I don't know why they're so expensive, but they are. Um, yeah, the RS1, crazy money. So on a C22 with the tool changer, or the bigger tool magazine, I should say, and the RS1 with the empty RS1, it's like 1.4 million or something like that, or 1.3 million. Like it's just a lot, and that's empty.
Right.
So it would have been really difficult for me to sell that,
Yeah. Be like,
especially
hey,
seeing
I need $2 million to do this.
exactly, especially seeing just now. Like I would have been, I would have, yeah, I would have got hung for that. Um, but it would be cool. We'd have an
Right.
RS1, like, yeah,
Yeah.
one of the only ones in the United States, at least at the time. So Hermele was cool. We vetted them out, and that they're still a contender for our next machine once we need a machine with HSK 63. And, if we start getting into work that requires a bigger spindle, yes, we
Yeah.
need that.
A C250
Um,
is on my possible list of next machines because it's
Sweet.
fairly well priced. Um,
Totally.
I mean, comparable to it's within, it's very close to like a Doosan DNM, what 5,000 or whatever they're called, or not
Mm-hmm.
DNM, DVF 5,000. Like they're not that far apart, and it's
Yeah, they're
such a
like
good machine.
300,000 or whatever.
Yeah, yeah. So
Yeah.
it's pretty
I'll
cool.
tell you what, the one that I got to see at emo, the video that I posted of them making the pretzel,
Hmm.
um, it was so cool just like standing there in front of it, and and hearing it and seeing it and being like, wow, this thing is a freaking tank. Like, and to think that it's kind of weak compared to other machines out there. It's like crazy to me. Like it's just crazy to think that this thing, yeah, you should get a C250. That would be awesome.
Yeah, we'll see. Fingers crossed. That would be awesome.
That would be so cool. And GF was another one with like the HSM 400 and 600 or Micron, whatever they are.
Yeah,
Mill P, or I forget now.
Mil S 400U or whatever.
Yeah, Mill and Mill X.
Yeah.
Um, Matt Sura was in there with the MX, but I figured MX 330, like we would, and I'm glad we didn't get one because we would have outgrown it in a heartbeat.
Yeah.
90 tools is not enough. 10 pallets is not enough. We have more pallets now in a box. Um, uh, the The MAM was pretty uh, kind of cool.
Those are
MAMs are
sweet.
cool.
Yeah,
Definitely pretty sweet. Um,
very expensive.
yeah, pretty expensive. But up there, so basically, for anybody who doesn't know how much these machine tools cost, anything with an expanded tool changer and automation is going to be 800, 700, more like 750 plus.
Yeah.
So, like, the MAM is like an $800,000 machine. You know, Kern is $800,000. The Hermele obviously is more. It's just crazy how much these things cost. And you're like, yeah, so thank goodness not my money, but it'll be your money. So, yeah, have fun with that. Hopefully it's good. I'm sure you'll make it work.
Yeah, I was just talking to somebody the other day about like how 2 years ago I was dreaming of a new machine, or I guess 3 years ago at this point, and like now we've got two new machines, and it's like it just compounds, and like
It's so crazy.
the bigger numbers get more palatable, and
Yep,
it still hurts when you like sit down and actually think about it. You're like, oh wow, that's dumb, but like in a business sense, you're like, well, it makes sense though. Okay,
it does. It does. Absolutely. Yeah. You just got to be educated on it, right?
yeah,
So, the Kern, so we went through all these machines. The machine that I really kind of wanted, like the machine that I think really fits our bill, is called a Fellman uh, Versa 645 linear or something like that.
okay,
And it's a German machine. I think it's German, or is it Swiss? One or the other. But there's no USA support.
mm,
Can't get it in the U. You could get the machine. The guy told me, he's like, oh, we'll sell it to you, but if there's any problems, we have to send a guy from Switzerland.
right.
Um, but that machine has a HSK 50 spindle and linear drives, so like linear motors. So
So it's quick.
it's kind of quick, yeah, kind of like perfect. So anyway, I was really leaning towards Hermele, but they're expensive. And so, yeah, Makino DA 300.
Yeah, that thing's killer.
Yeah, it's a pretty cool machine. So there was a point in time when I was just ready to say we need to buy the Makino DA 300 with an Aroa Compact 80. And price is in line. It's like 750K or whatever. They had good lead times at the time. Forget about it now. I think they even had machines in stock at the time.
Oh wow.
Yeah. And DA300 is wicked, wicked quick. Um, and just, yeah, it would do the trick. But we didn't get it. Only 20,000 RPM, right? So we do a lot of stuff that has tools that are smaller than 3 millimeters. So like the Haas spends most of its life at 15,000 RPM.
Right.
Some days it's just like seems like it's always there. So anyway, back to the story. Makino, we were really close on the Makino. I was close to just having it in my gut, saying this is it. This is right. I believe in this decision. And we didn't do anything with it. Kind of had to the project kind of got, I don't know, it didn't stall, but it took some time. So time passed. I actually met Marv in person, Marv Grobe,
Mhm.
who a lot of people know. I met him in person at Emo, and we talked about some things. And him and I became friends. He visited. He was in my town around here, and it kind of hit me. And the Kern guys were saying this from day one. So Dan and Tony from Kern were saying, you spend a lot of your time finishing. You don't spend your time roughing. And I'm like, but we do these big blocks and we need to get all this material roughed out. And Dan goes, well, how much time are you spending roughing? And I showed him, he's like, yeah, see, and this was like 2 years ago, right? So it took me a really long time to figure that out for myself and like understand it myself. And once I figured that out, that concept that we're really not spending a lot of time roughing, we're spending all the rest of the time finishing,
Right.
right? Every feature that you're putting on the part that is a finished feature is that's what the part is left with. You're not left with roughing. You're not sending your customer something that is just roughed. If that's
Right.
what we did, we would buy a big machine with an HSK 100 spindle and take it in one pass, right? So, no, we're doing things that are fine, semi fine details, like not really small, but, running 1 millimeter or half a millimeter or 0.3 millimeter ball mill, like stuff like that will do.
It's pretty small.
And yeah, it's pretty small for only 15,000 RPM.
Yeah.
But so then I'm like, okay, this is starting to make a little more sense. And then Marvin told me about this thing called jerk, like you're a jerk. This concept, it's a physics concept,
Yeah. It's what the
jerk.
derivative of acceleration.
Yeah, I'm sure. Yes, it is. So it's like how quickly, if you're in a car, how quickly can you apply the accelerator? Like
Right.
how quickly can you apply the acceleration? How quickly, how much acceleration can you accelerate the? Yeah, it's
Yeah.
weird. I don't
How
I don't quite
quickly
get
does
it.
acceleration change over time, which is a crazy
Yeah,
concept. Yeah.
right. So the like if you think about an electric car, they probably have to turn it down a little bit so it doesn't just break everything because of the amount of torque that's instant.
Right.
Yeah, right? You get that instantaneous torque. So they probably have to kind of let that ramp up a little bit. So similar with a machine tool, if you have a big heavy machine tool, yeah, you could put full power to the servos and probably break everything, right? The machine doesn't have that jerk. And Marvin's probably going to listen to this and be like, Alex, you're explaining it all wrong. But that's fine. He can do that. That's fine.
He can come back
Um,
on the show and tell us both how dumb we are. It's
there,
okay.
there, yes, yes, he can explain jerk to the machinist community.
Yeah.
But so a machine with a very high jerk is a machine like a Kern or rotors, right? You see the videos of the rotors, and they're like stupid quick, like really quick, and also tracing very, very tight paths, very tight tolerance paths. So the ability for the machine to change direction and just it's almost like lightweight. Like it's so lightweight that it's like quick, but it's really not. Anyway,
Right.
I don't know how to describe it more than that, but it's the ability. What it translates to for somebody like us, people like us, it's okay. You want to mill a slot. Like you imagine taking that slot that you were talking about, but make it really small. So make it a 1 millimeter slot, it's 1 millimeter wide, or let's say 1.5 millimeters wide, or 60 thousandths wide, and make it a half an inch long. And now make it, 10 or 20 millimeters deep or something like that. Those are features that we have to make.
Oof.
So yeah, if you have a machine that can, if you're so your tool of choice is going to be at least for me, it's a high feed mill. It's a little tiny high feed mill, solid carbide, obviously. And we go back and forth like a million times and ramp at a very slow or very low Z engagement. And it takes time to do it on a slow machine that can't just change direction like in a jiffy.
Yeah.
And so this was something that I realized, well, we do a lot of this stuff. We do a lot of these parts where there's a lot of complex features that have a lot of directional changes in the program. And yeah, we spend our time finishing. It's like no duh, right? And once you start to think about that and you start to play with some feeds and speeds and you go like, yeah, we can actually run that tool that quickly and we can run it that quickly, we can spin it that fast, and we can actually hold feed rate, which is key to tool life where you're still taking a chip, right? You're
Right.
not rubbing in the corner because it slows down so much. Now you just rubbed your tool at 40,000 RPM and it's taking like a 0.000000001, chip load. Um, so, so yeah, it's kind of the realization of that helped a lot and understanding that, yeah, We don't need the machine to like rough like crazy. And then once I kind of learned a little bit about that for myself and talked more to Marv, he made it really pretty awesome. He made a trip possible for us to come and cut apart. So one of these Nitronic 60 parts, and if you look at Instagram, you'll see like Nitronic 60 part on being cut on a Kern. That was at Kern with Marvin. Taking my existing program from, a machine that's already running these parts, and we took the cycle time and cut it almost in half, and which is pretty cool. Now a lot of that's just from the speed of the machine, but also, we turned some stuff up and we were able to run higher RPM and process the part, like processing the features faster. Um, Taking those micron plunge and slot, those 3 flute micron plunge and slot end mills. And like, I have a hankering that running cutting oil, you can crank the RPM and you still get tool life on those things. So like a 3 millimeter tool that we're running at 15,000 RPM now, it's just pegged, but it's 140 meters. I want to run that at 250 meters and do like full slotting and just crazy, crazy stuff. That's like, I don't know what that would be, 30 something thousand RPM on a 3 millimeter tool in steel or in stainless.
Right.
So like doing stuff like that is now going to be possible. And it's going to be super cool. So like, I think I want to plan when we get the machine, I want to take some big blocks of 17.4 and just test, just do some features and just get an idea of tool life and some of the stability of the process, and just be like one of these YouTube video or like Freza, right, where they just cut slots all day long or
I was gonna
whatever,
say
and
make a terrible heatsink out of 17.4.
exactly make like the world's worst heatsink. Um, so that'll be kind of fun, just getting everything dialed in and turning up what we already know or what our processes already are, just turning them up to be faster. And yeah,
That's epic.
hopefully it works. There's still some unknowns, but I think we'll be okay.
I think you'll make it work. Definitely.
I think so. It'll be fun. So yeah, end of the year. It's gonna be exciting. I'm excited.
Yeah, that's badass.
Yeah, it's
Well,
cool.
that brings me to the last question I ask every guest every time, which is, what did you research this week? And it could
Oh
be
yeah.
anything under the sun. Doesn't need to be machining. Could be cars. Could be whatever.
So I didn't really research anything. I don't know. I spent some time watching that YouTube channel, Machine Thinking. Is that what it's called? Machine Thinking, where he's got the videos called Origins of Precision, I think.
I
And
think I've seen those. Yeah.
yeah, he's got like these really good videos. They're pretty well made, and he's got some on like screws that changed the world, and it's like the screw on the printing press, right? Stuff like that. That was kind of cool. And the one that stuck out was the really big stuff in America, like this, and these giant presses, these huge presses, like a 50,000 ton press,
Yeah.
50,000 tons. So what was it like? What that means is, so the press, to put it into perspective, has a 12-foot by 26-foot platen. 12 by 26.
That's just bananas.
It's insane. And the amount of force that it puts on would be if you took 12 by 26 by, basically, if you took a piece of steel that was 12 feet by 26 feet by 600 and something feet, solid steel, 600 foot tall. That's like a giant skyscraper, right?
Right.
600 feet tall and 12. It's just insane. That's how much weight, that's how much force the press puts on. So like stuff like that, I don't know. That's kind of cool. I didn't go out of my way to research it. Something that I tried to research was I was talking to my coworker, because we're constantly looking for, I feel not we, but I'm like constantly looking for something to wipe my hands off with, because we run oil, so there's always oil everywhere. And it's fine. It's just that you get like
That
we
sounds
got
like
the wipe.
Stockholm syndrome to me.
Right. We've
It's
got
fine. It's
it's
fine. I
fine.
love it. It's so good.
It is, right? It's great. We get we get these giant rolls of paper towels. They're not paper towels. They're the wipe all ones that are kind of cloth a little bit.
Yeah.
So they they have more strength and they last. Not like paper towels where yeah, anyway. I don't know if you remember or if you've ever seen it, but ever been in a bathroom in a restaurant or an airport or
With the rolls.
something? Yeah.
Yeah.
Yeah, with those cloth rolls.
I know exactly what you're talking about.
Yeah, and I'm like, Ed, I said, Ed, we need this. Like, I want one of those roll things, and it's just like cloth. And I think they're recyclable. And I'm like, did you ever see that? He's like, I don't know. I don't know. You don't see them. I haven't seen one in years.
No. I'm
Like,
sure they've been labeled not sanitary and
most likely, yeah, with COVID, it's probably all gone.
yeah.
So anyway, I spent like, he was searching too. We're trying to find better things to wipe off our hands. And I found it finally. So it's called a continuous, I think it's called this, a continuous cloth roll. Uh, if you type dispenser, it would probably work. But the thing is made by Darman, I think Darman, and it's called an Endura 2. Anyway, I found it.
Awesome.
They're like $300 with a roll in it. But yeah, the roll just continuously rolls back up into itself, and I think you can put them in the laundry.
Right.
Like you can probably have a service laundry these rolls. But I don't think we're gonna get them.
No?
I don't know. Like, what are you gonna do? Put them everywhere? Put them on each machine? They're 200. It would eventually pay for itself because those rolls of white balls are like $100.
Yeah, they're not cheap.
They're not cheap, and they go into the landfill, so it's not really friendly to Mother Earth,
Right.
right?
Maybe magnet one to every other machine or like
Yeah,
every 3 machines for now and then
yeah.
slowly add them.
They're pretty big and pretty hardcore contraptions. They have chains inside and stuff. It's
Oh,
like
really?
pretty. Yeah, they're beefy. I think they're made in the USA and all those great things.
Oh,
So
very cool.
yeah, but yeah, one of those weird cloth things. That's what I was researching. It's a pretty horrible answer. So
The question I love posing because it's always that weird boutique stuff that I would never like. If you had been like, guess what I researched this week,
yeah.
it would not even have been
What
in my first 1,000 guesses.
what did you research this week?
Oh boy. Well, actually today I was researching because I got spam mail. Makino has a new 3-axis called the Slim 3N. And so it's
Okay.
a HSK, I want to say it's HSK 50, either a 16K or an 8K, which I don't know why you would get an 8K, but
Mm-hmm.
it's like super skinny, 26 tools. Looks like you can get it with like an integrated mist collector, integrated conveyor. To me, it looks like something that's trying to compete with like Robodrills and Brothers. And so
Yeah, it has a ring tool behind it, kind of like a Hermley.
I'm not sure that the product page is very bare. Like they're like, look
Yeah,
here, look at the
Makino's
3D
really horrible
model.
like that.
Yeah.
Okay. I think they have one that's like a horizontal, not a horizontal, but it's got like a fourth axis, like a big fully swiveling thing, and it's super small, like a phone booth. Um, and yeah, it's got a ton of tools in it. Not a ton. I think it has like 20. What am I
Yeah.
thinking? 20 or 30 tools. Well, that's kind of cool. You
Yeah.
gonna
So
get one?
probably not, but I'm curious of what they cost. Like
Yeah.
I want to get a quote just to see because I mean, Makino makes great machine tools. So if it's price competitive with Brothers and Robo Drills, it's interesting to know.
Yeah, there's another one too that most people don't know about, and Tornos makes one.
Really?
Yes, Tornos makes a. It's actually 6-axis.
Tell me
So
more.
yeah, I forget what it's called. I don't know if they're available here. I don't know if they're available yet, but it's basically like a Tornos robo drill, but with a trunnion and then with a like a handoff to a vise from the
That sounds
trunnion.
awesome.
Yeah, it's pretty rad. Um, yeah, I'm sure you could find it pretty easily on their website. I think it's like right on there.
I'll check it out after this.
But
That sounds really cool.
yeah, yeah. So check that out. It's pretty sick.
Yeah, and then the other thing I've been researching is Brother just released their new U500 that we were all hoping was going to be full five, but at least on the Japanese website right now is just a 4+1. But it's
Oh,
basically like
really?
their 500 millimeter machine with a integrated trunnion on it. And so that was, I spent a lot of time rewatching the single demo video and going through the Japanese website and looking at specs and stuff.
So your brother, does yours have the turning spindle?
No,
Yours is just a 3-axis,
yeah, I've got one that's just a 3 axis and one that we've got a 4th axis on.
which is the new one has the 4th axis?
Our older one has the 4th axis.
Okay.
Yeah, we'd considered putting it on the new one, but the new one's really nice for like bigger hog outs and stuff because it's a high rigidity model.
Oh, cool. And yeah, we were actually just talking about this today, and the HSK 40 versus a brother, right? Like a Kern. I'm saying I'm like, no, I'm pretty sure the brother is going to be stronger with the dual contact, um, 30 taper. It's just a stronger interface, right? So what's your take? I have a feeling it's probably pretty beefy, right?
It's I really think it's not that bad. I know a lot of people like think like, oh, 30 taper is just a toy, blah blah blah. But like,
Mm-hmm.
we can take some pretty decent cuts, especially on our F600, which is the high rigidity model. Like that thing, it was so funny. So brother didn't really do great marketing on them. I had heard rumors that like it was tested and they're like, oh, it's not actually any more rigid than the S series or whatever. And like, I have them back to back, and it is significantly more rigid.
Okay.
Like it's an extra, just in weight alone, it's like an extra 3,000 pounds.
Oh, wow.
And then the table only moves in Y, and then the X is a traveling head X, and it's personally, I think it's significantly more rigid.
Yeah. Yeah. That's
But
awesome.
they're both fairly rigid machines. I've never run HSK, so I can't really comment on to
Yeah.
how it works, compared to 40. But I like it. Like the machines are great for the price.
That's so cool. Yeah. Is this like the world's longest podcast?
I think we're 30 minutes short of my longest one so far.
Oh, yeah. I don't want to be the longest one.
No,
I
it's
mean, I
okay.
could be, but yeah.
No, I think this is a great place to wrap up. I really appreciate you taking the time. You're more than welcome
Sure.
back on because I feel like we touched on many subjects that I'm sure people are going to write and be like, well, why didn't you go more into tool selection or why didn't you go more into container method? And it's like, because that's
Yeah.
a 2-hour podcast in and
I
of
could have
itself.
we could do a whole podcast on standardization and building a process for 5-axis prototype.
Well, it's a deal. I'm more than happy to have you back on. I really appreciate you taking the time, though. I know that
Yeah.
you're busy, and I really, really appreciate it.
I'm only busy at work.
Well,
Well, yeah.
real quick before we go, new Patreon thank you to Nicholas Graham. Thanks for backing the show. Helps me send headsets to people like Alex so that we can have
Yes.
conversations that you guys can hear.
Thank you, Nicholas Graham.
And thanks to everyone who backs the podcast. Thanks everyone for listening, and I'll be back next week.